Hello there, and welcome to Just About Earth, where curiosity gets comfortable, questions are allowed to stretch out a little, and science takes the long way home. Wherever you happen to be listening from tonight, whether it's late evening with the lights already dimmed, or early morning before the world fully wakes up, I'm glad you're here. Before we settle in, take a quiet moment to notice where you are. Maybe you're lying in bed, or sitting with a warm drink, or letting this play softly in the background while the day winds down. And if you find this kind of slow, wandering soothing, or simply enjoy letting your mind wander without needing to arrive anywhere in particular, liking the video or subscribing helps this small corner of calm reach others who might need it too. Now, let me ask you something gently, without expecting an answer. When you think about human history, how complete does it feel to you? Most of us carry around a familiar picture: stone tools and cave paintings, the rise of farming, cities, writing, empires, machines, computers, space probes. A long, impressive climb from simplicity to complexity. It's a satisfying story, neatly ordered, with us standing at the very top looking back down the slope. But sometimes, especially when you slow down and really sit with the age of the planet beneath your feet, that story starts to feel a little narrow. Not wrong exactly, just small compared to the vastness it's trying to describe. Earth is very old. That fact alone is easy to say and surprisingly difficult to feel. Our planet is about 4 billion years old. Modern humans, by contrast, have existed for roughly 300,000 years. If Earth's entire history were compressed into a single 24-hour day, humans would appear in the last few seconds before midnight. All of recorded history, everything from the first cities to this very moment, would fit into a fraction of a second so small it would be hard to point to it on the clock face. And yet we often talk as if we've been here a long time, as if we've seen most of what this planet has to offer. That contrast leads to a quietly unsettling question. What if we are not the first technological civilization Earth has hosted? What if humanity is not the beginning of intelligent complexity here, but simply the latest expression of it? Not aliens from the stars, not visitors from elsewhere, but something that arose right here, long before us, lived for a while, and then vanished so completely that only the planet itself remembers. At first, that idea can sound like science fiction, or the kind of speculation you'd expect to hear late at night when conversations drift toward the strange and improbable. But it doesn't require fantastical assumptions. It doesn't ask for advanced flying machines or lost superweapons buried under deserts. It simply asks us to take deep time seriously, to really think about how long Earth has been active, dynamic, changing and alive, and how fragile the traces of any one civilization might be when measured against millions of years of erosion, plate tectonics, ice ages, floods and biological recycling. We tend to imagine that anything advanced would leave obvious scars, massive ruins, indestructible artifacts, clear signatures that scream, "Someone was here before you." But that assumption comes from living inside our own moment, surrounded by materials and structures that feel solid and permanent. Steel, concrete, plastic, satellites. It's easy to forget how temporary all of this actually is when the clock runs long enough. Consider what happens when cities are abandoned even for a few centuries. Plants move in quickly, roots pry apart stone. Water finds its way into every crack. Metal rusts, wood rots, glass breaks down into sand-like fragments. Given enough time, buildings collapse, roads crumble, and what was once unmistakably human becomes difficult to distinguish from natural debris. Extend that process from hundreds of years to tens of thousands, then hundreds of thousands, then millions, and the picture changes dramatically. Earth is not a museum that preserves exhibits behind glass. It is an active system that erases, recycles and reshapes almost everything on its surface. Continents drift, ocean floors are subducted back into the mantle, mountains rise and are worn flat again, entire ecosystems come and go. Most species that have ever lived are now extinct, and many left no clear fossils at all. Preservation is the exception, not the rule. Even fossils, which feel like solid proof of deep history, are rare accidents. For an organism to fossilize, a precise set of conditions must be met: rapid burial, low oxygen, the right chemistry. Most living things simply decay and disappear, their atoms reused by new life. If that's true for bones and shells, things that are naturally hard and structured, imagine how much more fleeting, softer traces of activity might be. Now, think about technology. We often picture advanced civilization as synonymous with heavy industry, sprawling infrastructure and permanent marks on the land. But that reflects our particular path, not an inevitable one. A civilization could develop technologies that are biologically integrated, or that rely on materials which break down cleanly. It could favour compact designs, minimal surface disruption, or even exist primarily in environments that are especially hostile to long-term preservation, such as coastlines or dense forests. Even our own technological footprint may not last as long as we assume. Plastics persist for a long time by human standards, but under heat, pressure and geological processes they too break down. Radioactive materials decay. Satellites eventually fall from orbit. Digital information disappears almost instantly without constant maintenance. In a million years, what unmistakable sign would remain that clearly says, a technological species once dominated this planet? It's tempting to answer confidently. Surely something would survive. Surely there would be evidence. But the more carefully scientists look at the geological record, the more they realize how incomplete it is. There are vast stretches of time where we know very little about what was happening on land, especially far from places where sediment accumulated in just the right way. Absence of evidence in deep time is often exactly what we should expect. This idea has even been explored seriously by scientists, not as a claim, but as a thought experiment. One well-known example is sometimes called the Silurian hypothesis, named after a geological period long before mammals existed. It asks a simple question. If an industrial civilization had existed tens or hundreds of millions of years ago, would we necessarily be able to detect it today? And the surprising answer is, not easily. Certain chemical signatures might show up, like unusual carbon ratios or traces of synthetic compounds. But many of those signals could also be explained by natural processes, volcanic activity, or climate shifts. Distinguishing between a natural anomaly and a technological one after such immense time gaps would be extraordinarily difficult. The planet has had many dramatic episodes on its own without any intelligent help. What's important here is not to assert that such a civilization definitely existed, but to recognize that our confidence in being the first rests more on assumption than on absolute proof. We are very good at telling the story of what we know. We are less comfortable sitting with what the evidence cannot rule out. There's also a subtle psychological factor at play. Humans tend to place themselves at the center of narratives. It's natural. We experience the world from here and now, so here and now feels special. But from Earth's perspective, this moment is just one frame in a very long film. No title card announces that the story truly begins with us. No guarantee says it won't continue long after we're gone. Possibly with new characters, new intelligences, new ways of interacting with the planet. And when you start thinking along those lines, the question shifts slightly. It becomes less about proving that someone came before us, and more about understanding how temporary any civilization might be, including our own. Intelligence may arise, flourish, and fade, not once, but many times, depending on conditions. Earth has already seen multiple mass extinctions that reshaped life almost entirely. There's no rule that says intelligence gets a permanent exemption from that cycle. Even now, our civilization depends on a very narrow window of environmental stability. A stable climate, accessible energy sources, predictable seasons. Change those parameters enough, and complex societies become difficult to sustain. In the deep past, conditions on Earth have swung wildly. Ice ages that covered continents, Greenhouse periods with no polar ice at all, massive asteroid impacts, supervolcanoes, each of these could reset the board in ways that make long-term continuity nearly impossible. So if intelligence emerged earlier, perhaps in a different form, under different conditions, it might not have lasted long enough to leave a lasting mark, or it might have chosen paths that didn't scar the planet in ways we'd immediately recognise, or its traces may simply be buried, recycled, and scattered beyond recovery. This perspective doesn't diminish humanity. If anything, it places us within a much larger, humbling context. We are not standing at the end of history, but somewhere in the middle of a much longer process. We are a chapter, not the book, a phase, not the final form. And there's something quietly calming about that idea. It takes some pressure off. It reminds us that the Earth is not defined by us, and never was. We are participants in a story that began long before our ancestors looked up at the sky, and will continue in ways we cannot yet imagine. As this thought settles in, the planet beneath you starts to feel different. Not just as ground or scenery, but as an archive that has been written over again and again, its older pages worn thin, rewritten, and sometimes completely erased. What we see now is only the latest draft, and that naturally leads to another question, one that waits patiently just beyond this moment. If the Earth has hosted many eras we barely understand, and if our sense of history is shaped by what happens to survive, how confident can we really be that the story we tell ourselves is complete? There is a comforting feeling that comes with a complete timeline, a sense that the pieces line up neatly, that the story has been told from beginning to end, and that all the important chapters are accounted for. Human history, as it's often presented, carries that comfort. We move from early stone tools to farming, from villages to cities, from writing to industry, from steam to silicon. Each step follows the last with reassuring logic. It feels whole, it feels settled, it feels like we know where we came from. But that feeling starts to wobble when you place that tidy narrative against the age of the Earth itself. Because while our historical timelines stretch back thousands of years, and our archaeological timelines stretch back tens of thousands, the planet beneath them stretches back billions. The imbalance between those scales is so extreme that it's almost impossible to intuitively grasp. Our entire recorded history, all the wars, discoveries, collapses, renaissances, philosophers and technologies, occupies a geological eye blink. And the farther back you look beyond that blink, the quieter the record becomes, not because nothing was happening, but because so little survives. This is where the sense of completeness begins to feel misleading, not false, but incomplete in a deeper way, like reading the final pages of a very long book and assuming you understand the opening chapters because the ending makes sense on its own. Archaeology, for all its remarkable achievements, works with fragments, broken tools, partial skeletons, charcoal traces, post holes in the soil. From these, entire cultures are reconstructed with care and caution. But even under ideal conditions, archaeology becomes increasingly blind as time stretches backward. Organic materials decay, landscapes shift, sediments bury evidence. The deeper you go, the more silence you encounter. Geology operates on a completely different timescale, and it tells a very different story. Continents drift several centimetres a year, which sounds slow until you remember that millions of years are available. Ocean floors are constantly being destroyed and renewed through plate tectonics. Most of the oceanic crust on Earth is less than 200 million years old. Anything built on it before that is simply gone, dragged down into the mantle and melted away. Entire surface histories are erased without a trace. Even on land, stability is temporary. Rivers change course, deserts expand and retreat. Ice sheets advance and grind landscapes flat, then melt and leave behind rearranged terrain. Forests come and go. Volcanic eruptions blanket regions in ash. Over long enough spans, the surface of Earth is not a static arc. It is an editing process. So when we say we have a complete picture of Earth's past civilizations because we haven't found evidence of earlier ones, we are quietly assuming that evidence would survive by default. That assumption feels reasonable on a human timescale, where buildings can last centuries and monuments millennia. It becomes far less reliable when stretched across tens or hundreds of millions of years. There's another subtle assumption embedded in our confidence. The idea that civilization must look like ours to be recognizable. Cities, roads, mines, large-scale agriculture, heavy industry. But that is just one expression of organized intelligence shaped by our biology, environment, and historical contingencies. It's not a universal template. Imagine a civilization that developed primarily in coastal regions, drawn to abundant food and stable temperatures. Coastlines are among the most geologically active and destructive environments. Sea levels rise and fall dramatically over geological time. Entire continental shelves that were once dry land are now submerged. Anything built there would be drowned, scattered, and eventually buried beneath sediments. We already know this has happened to early human settlements from much more recent history. Now stretch that process across millions of years, and the probability of survival drops further. Add tectonic movement, sediment compaction, chemical alteration, and biological activity, and even stone structures lose their clarity. What remains may no longer look artificial at all. There is also the matter of materials. Much of what we associate with modern civilization relies on energy-intensive extraction and processing of metals. But metals are not inherently permanent markers. They corrode, dissolve, and redistribute. Iron rusts, aluminum oxidizes, copper weathers. Over time, metal artifacts break down and their constituent elements re-enter natural geochemical cycles. After enough time, they no longer stand out as objects, they become chemistry. Plastic feels like a different case, and it's often cited as something future geologists will clearly recognise. But plastics too degrade under heat, pressure, radiation, and chemical processes. They fragment into smaller molecules, then smaller still. In deep geological context, they are unlikely to remain as recognisable objects. At best, they might leave unusual chemical traces, but even those could be ambiguous when separated from their context. The same applies to digital civilization. Data feels permanent because it can be copied endlessly, but it is among the most fragile forms of information ever created. Without constant maintenance, digital records disappear almost instantly. Hard drives fail, servers corrode, formats become unreadable. A civilization could generate enormous amounts of knowledge and still leave almost nothing behind, if that knowledge wasn't continually rewritten into durable forms. So the completeness of our historical picture depends not only on what happened, but on what survived. And survival is highly selective. There's an analogy here that helps. Imagine arriving in a city centuries after it has been abandoned, but most of the buildings were made of wood, the roads of packed earth, and the tools of materials that decay easily. A few stone foundations remain, some scattered objects. From that, you might infer a small, simple settlement, even if it was once complex and populous. Now imagine trying to do the same thing millions of years later, after earthquakes, floods, and rebuilding have erased even those foundations. This is not speculation detached from reality. We already see it in our own past. Entire cultures known to have existed left behind surprisingly little. Some are known only through second-hand references, others through subtle soil disturbances or faint patterns in satellite imagery. In some cases, we only know they existed because something else, like pollen records or genetic traces, hints at their presence. And these are cultures separated from us by thousands of years, not millions. When we zoom out far enough, history starts to look less like a continuous record and more like a scattering of islands rising above a vast ocean of missing information. What we call prehistory already covers most of our own species' existence. Everything before writing is reconstructed indirectly. Everything before agriculture becomes even hazier. Beyond that, the record thins rapidly, yet Earth itself shows no sign of long quiet periods. Life has been abundant, diverse and innovative for hundreds of millions of years. Complex ecosystems existed long before humans. Intelligence, at least in limited forms, appears in many lineages. Tool use, social learning, communication, problem solving. These traits are not unique to us. They are part of a broader pattern of biological experimentation. That raises an uncomfortable possibility. If intelligence and complexity are not flukes, but tendencies that can emerge under the right conditions, then Earth had a lot of time to try again and again before we arrived. Still, caution is necessary. None of this proves that an earlier civilization existed. The point is not to replace one certainty with another. It's to examine how confident we should be when the evidence is filtered through such extreme temporal bias. We know far more about the last few thousand years than we do about the last few 100 million, not because the recent past was uniquely important, but because it's easier to see. And there's another reason the story feels complete. We like narratives with clear beginnings. The idea that humanity rose from simplicity to complexity fits well with a progress-oriented worldview. It flatters us. It places us at the forefront of something inevitable. The first, the pioneers, the ones who finally figured it out. But Earth does not owe us that framing. From a planetary perspective, there is no guarantee that intelligence appears only once. There is no rule that says the first technological species gets to stay indefinitely. There is no cosmic plaque declaring ownership. When history feels complete, it's often because we've reached the edge of our tools. Our methods work brilliantly within certain windows, and then they fade. Beyond those windows, uncertainty grows, and our brains naturally fill that uncertainty with confidence rather than discomfort. There's also the human tendency to mistake absence of evidence for evidence of absence, especially when the alternative feels destabilizing. If we are not the first, then we are not unique in the way we often imagine. That can feel unsettling. It can also feel strangely grounding. Because if others came before and vanished, it reminds us that permanence is not guaranteed. It shifts attention from destiny to stewardship, from inevitability to responsibility. The Earth does not feel old in the same way a relic feels old. It feels active, restless, unfinished. Its surface tells a story of constant change, not preservation. And in that story, long stretches are missing. Not because nothing happened, but because time is not kind to records. So when we say we know our place in history, what we really mean is that we know our place in the part of history that survived long enough to be seen. Beyond that, there is space. Not empty space, but unlit space, where certainty fades and possibility quietly waits. As you sit with that, it becomes easier to understand why the idea of earlier civilizations is not about chasing hidden empires or rewriting textbooks overnight. It's about learning to be more humble with deep time, to accept that Earth's memory is incomplete, and that what feels like the beginning to us may simply be the most recent visible layer. There is a version of the past that lives comfortably in our minds. It is orderly, labelled, and mostly continuous. One era flows into the next with only a few pauses, a few mysteries neatly marked with phrases like, "not yet fully understood." It's a story we repeat often enough that it begins to feel complete, even inevitable. But when you slow down and look closely, not at the highlights, but at the spaces between them, something else becomes visible. Large stretches where the story goes quiet. Long intervals where we are no longer narrating events but guessing at them. These gaps are not small. They are not footnotes or minor missing paragraphs. Some of them span tens of thousands of years. Others stretch into millions, and they exist not because nothing happened, but because what did happen failed to leave traces we can still read. We tend to think of history as a record of events. In reality, it is a record of survivals. What we know is shaped less by what occurred, and more by what endured long enough to be noticed. This distinction matters because endurance is selective. It favours certain materials, environments and behaviours over others. Stone survives better than wood. Dry caves preserve more than open plains. Sudden burial protects better than slow exposure. Civilizations that align with these conditions appear louder in the archaeological record, while others fade into near invisibility. Even within human history, the gaps are striking. Writing, which many people treat as the beginning of real history, only appeared around 5,000 years ago. Everything before that, which includes the vast majority of our species' existence, is reconstructed indirectly. Tools, hearths, bones, traces of pigments. We infer language, culture, belief systems, and social structures from fragments that survived by chance. Entire lifeways, entire ways of understanding the world, may have existed without leaving anything we could easily recognize. And the further back you go, the thinner the record becomes. Early hominin species are known from a handful of fossils spread across vast regions and times. Sometimes an entire species is defined by a single jawbone or skull fragment. From that, we extrapolate behavior, diet, even intelligence. It's careful work, but it rests on very little material. A different burial condition, a slightly more acidic soil, and even that fragment might not exist. Now extend that same fragility beyond our own lineage. Earth has hosted complex multicellular life for over 600 million years. For most of that time, the land was populated by organisms whose remains rarely fossilized well. Soft-bodied creatures dominate early ecosystems, and they vanish almost completely from the record unless preserved under exceptional circumstances. Whole evolutionary experiments rise and fall, leaving behind only faint impressions, if anything at all. The geological record, often imagined as a neat stack of layers, is actually full of interruptions. Erosion removes layers as often as deposition creates them. Rivers carve away sediments. Glaciers scrape landscapes down to bedrock. Wind strips surfaces bare. What looks like a continuous sequence in a textbook diagram is, in reality, a patchwork assembled from many locations, many conditions, and many lucky finds. These discontinuities are known to geologists as unconformities. They represent missing time. Sometimes millions of years are simply absent from a sequence of rocks, not compressed, not hidden, just gone. Whatever was recorded there was erased before it could be preserved elsewhere. The planet moved on. When we look at those gaps, we rarely ask what might have existed there. We accept the silence as natural, even comforting. But silence does not equal emptiness. It only means the signal did not survive. There is also a strong cultural influence on how we interpret gaps. We are storytellers by nature. We prefer continuity, progression, cause and effect. Gaps feel like problems to be solved, or inconveniences to be minimized, so we often gloss over them with general explanations. Climate shifts, population declines, migration. These may be accurate, but they can also become placeholders that hide how little we truly know. Consider the so-called Dark Ages in European history. For a long time, this term suggested cultural stagnation or regression. In reality, much of what was dark was simply undocumented. Literacy declined in some regions, record-keeping shifted, materials changed. The absence of written sources created the impression of absence in general. As archaeology and interdisciplinary research expanded, that picture changed dramatically. Complexity had not vanished. It had just stopped leaving records in familiar forms. Now imagine similar gaps, not of a few centuries, but of hundreds of thousands or millions of years. Imagine shifts in record-keeping so complete that no familiar medium survived. No stone inscriptions, no durable monuments, no long-lasting infrastructure. Only activities that blended back into natural cycles once maintenance stopped. This is where the question of earlier civilizations becomes less speculative and more methodological. Not, did they exist? but what kinds of societies could pass through time without leaving durable, obvious signatures. Once you ask it that way, the list becomes surprisingly long. A civilization that relied heavily on organic materials, for instance, would vanish quickly once abandoned. Wood, fibres, resins, even early biopolymers break down rapidly under environmental exposure. Without constant repair, structures collapse and decay. Within a few thousand years, little remains that clearly signals intentional design. A civilization that favoured minimal environmental disruption might also leave a faint trace. Small populations, efficient land use, localised energy sources, these would blend into natural patterns once activity ceased. Even agriculture, which we often think of as a major marker, can disappear almost entirely if fields are reclaimed by forest or sediment. There is also the question of scale. We assume civilizations must grow large to be meaningful, but intelligence does not require planetary dominance. A technologically capable species might remain geographically limited or deliberately constrained. It might flourish briefly and collapse before expanding widely. It might never cross the threshold that produces unmistakable global signatures. And then there is time itself. Even if a civilization did leave clear markers, those markers would need to survive not just abandonment, but everything that followed. Sea level changes, tectonic activity, climate cycles, biological turnover. Over long spans, survival requires not just durability, but luck. We know this from our own projections. Some researchers have asked what future geologists might find if humanity vanished today, and Earth continued for another 100 million years. The answer is sobering. A thin layer enriched with certain elements, some unusual isotope ratios, possibly a brief spike in extinction rates. Beyond that, much of our built environment would be gone. Cities would crumble, metals would corrode, plastics would fragment and degrade, concrete would weather into limestone-like material. Would that layer clearly announce a technological civilization? Or would it be interpreted as one of many strange episodes in Earth's dynamic history? The more you think about it, the more the gaps start to feel less like anomalies and more like the default state. Continuous records are rare. Silence is common. We have built a story from the loudest surviving signals and assume they represent the full picture. There is also an emotional dimension to these gaps. A complete story feels safe. It tells us where we came from and implies where we are going. Gaps introduce uncertainty, and uncertainty invites questions without clear answers. Were there other intelligences, other rises and falls, other attempts that didn't last? Some people find that idea thrilling, others find it unsettling. Both reactions come from the same place. It challenges the notion that we occupy a uniquely privileged position in Earth's history. But acknowledging gaps does not diminish what we know, it actually sharpens it. It reminds us that knowledge is provisional, shaped by tools, preservation and perspective. What we know now is not the final word, it is the current draft. And this has practical implications. When we search for life elsewhere, for example, we often assume that technological civilizations will announce themselves loudly. Radio signals, megastructures, atmospheric pollution. But if Earth's own history shows us anything, it's that intelligences can be quiet, transient, or simply unlucky in how they're recorded. If we struggle to detect hypothetical earlier civilizations on our own planet, with direct access to its geology and biology, how confident should we be in our ability to detect them light years away? The gaps in our story are not just missing pages. They are reminders of how much depends on chance. A civilization could rise, explore, create, and collapse entirely within a geological heartbeat, leaving behind nothing that survives long enough to be named. This doesn't mean that every gap hides a lost civilization. It means that our certainty about what did not happen is often stronger than our evidence justifies. We fill the silence with assumptions because silence is uncomfortable. Yet there is something honest about sitting with those gaps, about admitting that much of Earth's past is unknown, not because it is unknowable in principle, but because the planet is very good at erasing its own tracks. And once you accept that, the story we tell ourselves begins to loosen. It becomes less rigid, less final, more like a sketch than a blueprint. We still see ourselves clearly in the foreground, but the background fades into suggestion rather than certainty. That fading background invites another line of thought. If so much can vanish, if whole stretches of history can dissolve into ambiguity, then what kinds of civilizations are most likely to leave nothing behind at all? And what does that tell us about the fragility of stories built on what survives, rather than on what simply happened? When we imagine a civilization, certain images tend to appear almost automatically. Cities spread across landscapes, roads cutting straight lines through terrain, monuments meant to endure, mines, quarries, factories, visible scars that say, clearly and loudly, someone was here, and they reshaped the world. That image is so familiar that it quietly becomes a requirement. Civilization, in our minds, must announce itself. It must leave marks that are difficult to miss. But that assumption is not based on necessity. It's based on familiarity. What we recognize as civilization is shaped almost entirely by our own example, and by the narrow slice of history we've managed to preserve. When you widen the frame, when you stop asking what must have happened and instead ask what could have happened, a very different picture starts to form. One where entire civilizations could pass through Earth's history, leaving behind little more than a whisper, not because they were primitive, but because they were temporary, localized, or simply unlucky in how their traces interacted with time. To understand this, it helps to start with a basic truth that often gets overlooked. Most of what humans build does not last very long. Even today, surrounded by modern materials, maintenance is constant. Bridges need repair, buildings crack, infrastructure decays, remove upkeep, and deterioration accelerates quickly. Within decades, abandonment becomes visible. Within centuries, collapse is widespread. Given enough time, everything trends toward dust and chemistry. Now imagine a society that never prioritized permanence, one that built with materials readily available in its environment: wood, plant fibers, resins, clay, bone. These materials are easy to shape, flexible and efficient. They're also extremely vulnerable to decay. Once exposed to moisture, microbes, insects and temperature changes, they break down rapidly. In most environments, they vanish completely within a few centuries, sometimes much faster. We know this not from speculation, but from experience. Many early human cultures relied heavily on organic materials. Their tools, dwellings, clothing and artworks were largely biodegradable. What survives of them is often limited to stone tools or accidental preservations in caves, bogs or frozen ground. Entire societies are known only because a few objects happen to fall into the right conditions at the right time. Now imagine a civilization that developed far earlier, long before humans, in a world that had not yet evolved widespread stone tool use, or one that deliberately avoided large-scale extraction and stone construction because it wasn't necessary or desirable. Such a civilization could be sophisticated in ways that do not translate into durable remains. Knowledge, social complexity and technological skill do not require stone monuments to exist. There is also the question of population size. We often equate civilization with large populations and expansive territory. But intelligence does not scale automatically with numbers. A small population with stable conditions, long lifespans and efficient systems could develop complex knowledge without ever spreading widely. If such a society remained geographically limited, its footprint would be correspondingly small, and therefore far easier for time to erase. Environmental context matters as well. Some regions of Earth are exceptionally poor at preserving evidence. Tropical environments, for example, are destructive to archaeological remains. High humidity, acidic soils, dense biological activity, and rapid plant growth all work against long-term preservation. Organic materials rot quickly. Even stone weathers faster. Metal corrodes aggressively. In these regions, traces disappear fast. If a civilization arose primarily in such an environment, its chances of being detected millions of years later would be extremely low. And yet, from the perspective of that civilization, its environment might have been ideal. Stable temperatures, abundant resources, reliable rainfall, plenty of food. Comfort does not correlate with preservation. Coastal regions present a similar problem. Coastlines are dynamic. Sea levels change dramatically over geological time. During ice ages, sea levels drop, exposing vast areas of continental shelf. During warmer periods, those areas flood again. Any settlements built there are drowned, buried under sediment, or eroded by waves. We already know that many early human settlements now lie underwater, invisible without specialized equipment, and that's after only a few thousand years. Over millions of years, entire coastlines migrate. Continental shelves subduct or are reshaped. Evidence that once sat comfortably on dry land ends up scattered across the ocean floor or crushed into rock. A coastal civilization, no matter how complex, could be erased almost entirely. There is also the issue of technological pathways. We assume that any advanced civilization must pass through heavy industry, widespread mining, and fossil fuel use. But that is only one route among many. A civilization that relied on renewable biological energy, chemical processes, or technologies integrated into living systems might avoid leaving behind the kinds of residues we associate with industrial activity. For example, imagine a society that mastered biochemical engineering rather than metallurgy, one that used modified organisms to perform tasks we handle with machines. Construction, energy storage, computation, even transportation could be handled through living systems that grow, repair themselves, and biodegrade naturally. Once abandoned, such systems would not leave factories or slag heaps. They would simply die and rejoin the ecosystem. Even energy use does not guarantee obvious traces. Fire leaves charcoal, but charcoal degrades. Electricity leaves almost nothing without infrastructure. Light, sound, and heat leave no fossils. A civilization could consume significant energy and still leave behind little physical evidence once its structures collapsed. Time compounds all of this. 1,000 years is enough to erase most surface traces of human activity if maintenance stops. 10,000 years erases almost everything except stone and rare preserved contexts. 100,000 years pushes even stone tools into obscurity. 1,000,000 years all but guarantees that only the most accidental signals survive. Beyond that, detection becomes extraordinary luck, and Earth offers more than enough processes to finish the job. Plate tectonics can carry entire regions into the mantle. Volcanism can bury landscapes under kilometers of lava. Glaciation can grind mountains into powder. Rivers can relocate tons of sediment every year. Forests can break apart stone with roots and acids. Life itself is one of the most effective erasers of structure. Even if a civilization left behind something unusual, recognizing it is not guaranteed. Interpretation depends on context. An isolated anomaly in the rock record might be dismissed as a natural oddity. Strange chemical ratios could be attributed to volcanic activity or climate shifts. Unusual formations could be explained as erosion patterns. Without a dense cluster of unmistakable signals, the story remains ambiguous. We already face this challenge with much more recent evidence. There are structures whose origins are debated for decades because the line between natural formation and intentional design is not always clear. Over deep time, that ambiguity only increases. It's also worth considering that not all civilizations may value expansion or permanence. We tend to assume that growth is inevitable, that technology leads to dominance. But that assumption reflects cultural values, not universal laws. A civilization might prioritize balance, stability, or continuity over growth. It might deliberately limit its population or footprint to avoid destabilizing its environment. Such choices would reduce long-term traces. They would also make that civilization less visible to future observers, including us. There is a quiet irony here. The civilizations most likely to be detected far into the future are those that are least sustainable. Large-scale mining, global pollution, mass extinction events. These leave sharp signatures. A civilization that avoided those outcomes might be almost invisible by comparison. From that perspective, the absence of obvious ancient civilizations could be interpreted in more than one way. It could mean none existed, or it could mean that any that did exist were either brief, localized, environmentally integrated, or erased by forces beyond their control. None of this requires invoking lost golden ages or advanced technologies beyond plausibility. It only requires accepting that durability is not a prerequisite for complexity, and that survival in the record is not a measure of importance. We are used to telling history from what remains. But what remains is a biased sample. It favours stone over wood, dry caves over open plains, catastrophic burial over gradual decay. It favours certain climates, certain behaviours, certain accidents. Entire ways of life could fall outside that filter entirely. And this brings the question uncomfortably close to home. Because if civilizations that leave almost nothing behind are possible, then we are forced to ask what category our own civilization will fall into. Not next year, not next century, but on geological timescales. Our cities feel solid now. Our technologies feel permanent. But permanence is relative. Remove maintenance, and entropy does the rest. Remove favourable conditions, and collapse accelerates. Remove time limits, and even the most impressive achievements soften, scatter, and vanish. This is not a pessimistic thought. It's a clarifying one. It reframes civilization not as a guaranteed upward trajectory, but as a phase. A pattern that can emerge, persist for a while, and then dissolve back into the larger system. Earth does not pause to preserve. It moves, reshapes, recycles. Whatever passes through must either adapt continuously or accept eventual erasure. So when we consider the possibility of civilizations that left almost nothing behind, we're not indulging in fantasy. We're acknowledging the scale of time, the power of natural processes, and the fragility of structures we mistake for permanence. And once that possibility is taken seriously, another thought begins to surface. If traces are so easily erased, if even complexity can dissolve into ambiguity, then the real challenge is not explaining why we haven't found earlier civilizations, but understanding just how little it takes for an entire chapter of Earth's story to be quietly overwritten, leaving us to read only what happened to survive. When we try to anchor ourselves in the deep past, we rely on a very small set of messengers: stone, bone, occasionally shells, teeth, or impressions hardened by chance. These are the materials that speak across vast stretches of time, not because they are especially meaningful, but because they are stubborn. They resist decay better than almost anything else. And because of that, they quietly shape the story we believe about the past. This creates a problem that is easy to overlook. Our picture of deep history is not built from what was most important, most complex, or most common. It is built from what happened to last. Stone tools dominate early archaeological narratives for this reason. They survive. A sharp-edged flake buried in sediment can persist for hundreds of thousands of years. Bone, under the right conditions, can mineralize and endure. Teeth are especially durable, which is why so much of what we know about extinct species comes from jaws and molars. But stone and bone are not a neutral sample of past life. They are a biased archive. If you imagine reconstructing modern civilization using only stone and bone, the picture would be deeply misleading. You might find concrete foundations and mistake them for crude stone structures. You might find animal bones in landfills and infer strange dietary rituals. You would miss electricity, medicine, mathematics, digital communication, music recordings, written literature, social institutions, scientific knowledge. None of those fossilize, and yet this is essentially the method we use for deep time. We infer entire worlds from fragments that survived long enough to be noticed. This works reasonably well for understanding basic survival strategies, diet, movement, tool use. It works less well for capturing social complexity, symbolic systems, or technological paths that do not rely heavily on durable materials. The deeper you go, the more this distortion increases. Bone itself is not guaranteed to survive. It decays rapidly in many environments. Acidic soils dissolve it. Warm, wet conditions accelerate breakdown. Scavengers scatter remains. Microbes do the rest. For a bone to fossilize, it must be buried quickly and protected from oxygen and biological activity. Most organisms do not receive that treatment. Most die and disappear entirely. Stone is more reliable, but even stone has limits. Stone tools erode, edges dull, surfaces weather. Over long periods, they can become indistinguishable from naturally fractured rock. Without clear context, identifying intentional shaping becomes difficult. Even today, archaeologists debate whether certain early stone assemblages are artifacts or geofacts, products of human hands or natural forces. Now stretch this uncertainty across millions of years. Context erodes, layers shift, sediments compress and distort, rocks metamorphose. What was once a clear tool might become a shape that could be explained in multiple ways. Interpretation becomes cautious, sometimes speculative. This matters because stone and bone are not the materials most civilizations would necessarily emphasize. They are simply the ones that remain when everything else is gone. Consider wood. Wood is one of the most versatile construction materials known. It is strong, flexible, renewable, and easy to shape. Many human societies relied on wood for housing, tools, transportation, and art. In most environments, wood does not survive more than a few centuries at best. Without special preservation, it vanishes completely. The same is true for fibers, textiles, leather, paper, plant-based composites. These materials can support remarkable levels of sophistication. They can carry information, form complex structures, enable trade and communication, and they almost never fossilize. Even metals, which feel more permanent, are deceptive. Iron rusts, copper corrodes, aluminum oxidizes. Over time, metals fragment and dissolve, their atoms redistributed through soil and water. Given enough time, they cease to exist as objects and become part of geochemical cycles. 1,000,000 years is more than enough. This means that a civilization's material culture could be almost entirely invisible if it favored perishable or recyclable materials. Its cities could collapse into soil. Its tools could break down into chemistry. Its knowledge could vanish with the last minds that held it. The problem deepens when we consider time itself. Deep time is not just long, it is transformative. Over millions of years, the Earth does not simply sit and wait. It moves, grinds, melts, compresses and rebuilds. Continents drift. Ocean basins open and close. Mountains rise and erode. Entire regions are subducted into the mantle and destroyed. Most of Earth's surface from deep time is simply gone. The oldest rocks on the surface are rare and heavily altered. Anything that once existed on younger crust that has since been recycled is irretrievable. No excavation will ever reach it. No technology can recover it. It has been physically erased. This means that the further back you go, the smaller and more selective your sample becomes. We're not looking at a complete archive that fades gradually. We're looking at a collection that has been aggressively edited. This editing is not random. It favors certain environments. Sedimentary basins preserve more than highlands. Calm waters preserve more than turbulent ones. Rapid burial preserves more than slow exposure. Civilizations that happen to exist in preservationally favorable settings are more likely to be detected. Those that did not are likely lost. This introduces a quiet distortion into how we think about the past. We assume that what we see is representative, that the forms of intelligence, organization and technology that left traces are the ones that existed. But this assumption rests on survival, not completeness. Bone and stone give us a skeleton of history. They do not give us its muscles, its nerves, its thoughts. This becomes especially important when thinking about intelligence itself. Intelligence does not fossilize. Decision-making does not fossilize. Language does not fossilize. Belief systems do not fossilize. Mathematical understanding does not fossilize. Even writing, unless carved into stone, disappears quickly. So when we say there is no evidence of earlier civilizations, what we are often saying is that there is no surviving stone and bone signature that clearly demands that interpretation. That is a much narrower claim. We already know that large parts of human history leave minimal material traces. Nomadic societies, for example, can be highly complex socially and culturally, while leaving very little behind archaeologically. Their knowledge systems, navigation skills, oral histories, and ecological understanding can be profound. Remove the people, and almost nothing remains to tell that story. Scale that up. Imagine a civilization that combined advanced cognition with minimal material accumulation, one that valued transmission of knowledge through living minds rather than durable objects, one that built lightly and moved with environmental cycles rather than against them, one that existed long enough to matter, but not long enough to dominate globally. Stone and bone would not tell that story. Even if such a civilization used stone tools or bone implements, those would represent only a tiny fraction of its activity. The absence of extensive stone architecture would not imply the absence of intelligence. It would simply reflect different priorities or constraints. There is also the issue of classification. Archaeology relies heavily on pattern recognition, repeated shapes, consistent tool types, standardized production methods. These patterns allow us to identify cultures, but pattern recognition depends on sample size. If only a few artifacts survive, patterns dissolve. What remains looks random. A civilization that produced a wide variety of tools, customized locally, might leave behind a scattered collection that never coalesces into a recognizable pattern. Without that pattern, interpretation stalls. Deep time amplifies this effect. Fragments are separated by erosion and movement. What was once a coherent system becomes isolated data points. The signal-to-noise ratio drops. Confidence fades. This is not a flaw in science. It is an honest limitation. Scientists are acutely aware of these biases. They build models carefully, revise them constantly, and avoid claims that go beyond the evidence. But public narratives often smooth over these uncertainties, turning cautious inferences into confident timelines. The result is a story that feels solid, but is built on narrow foundations. Stone and bone have given us extraordinary insight into the past. They have revealed our origins, our relatives, our adaptations. But they have also trained us to equate durability with importance, to assume that what survives must have mattered most. Deep time does not agree. From the perspective of millions of years, durability is a lottery. Preservation is an accident. Significance does not correlate with survival. When you place that understanding next to the age of the Earth, the confidence of a complete story begins to soften. Not collapse, but loosen. It becomes easier to accept that what we know is a thin slice through an unimaginably thick history. And this reframing leads to a different kind of question. Not, where are the ruins, but what kinds of evidence would we even expect to survive? What markers would be robust enough to cross geological eras? What signals would resist erosion, recycling, and reinterpretation? Because if stone and bone are our primary witnesses, then anything that did not rely heavily on them is effectively invisible to us. And that raises a further challenge. If our understanding of deep time is shaped by materials that survive rather than by activities that occurred, then our confidence in being the first may be resting on a very narrow filter. The Earth is old enough to have hosted many experiments. Stone and bone tell us about some of that. They do not tell us about all of them. It's easy to forget how much time existed before we arrived. not just in an abstract numerical sense, but as lived planetary time. Earth was not idle before humans appeared. It was not waiting quietly, empty and unfinished, saving its real story for us. It was active, dynamic, crowded with life, reshaping itself over and over again for billions of years. When we talk about how long the Earth has been waiting before us, the phrase almost sounds misleading, because waiting implies anticipation. In reality, Earth was busy. The planet formed about 4.5 billion years ago, emerging from the chaotic debris left behind by the formation of the Sun. In its earliest phase, Earth was hostile to anything we would recognize as life. Its surface was molten, its atmosphere toxic, its skies filled with volcanic gases and constant impacts. Yet even in that violent beginning, processes were already unfolding that would eventually allow complexity to arise. The crust cooled, water condensed, oceans formed, chemical cycles began their long work. Life appeared surprisingly early. Within a few 100 million years, perhaps sooner, the first simple organisms were already present. These early forms of life were microscopic, but they were not insignificant. They transformed the planet. Through metabolism and replication, they altered the chemistry of the oceans and atmosphere. Over immense spans of time, they introduced oxygen, changed mineral formations, and reshaped the surface of the Earth in ways that are still visible today. For most of Earth's history, life remained microscopic. Single-celled organisms dominated for billions of years. That alone is a reminder of how patient the planet has been with complexity. Multicellular life, the kind that builds bodies large enough to leave fossils, appeared relatively late. Even then, it took hundreds of millions of years for ecosystems to become richly diverse. During all that time, continents drifted. Supercontinents formed and broke apart. Mountain ranges rose and eroded away completely. Oceans opened and closed. Climate swung between extremes. Earth passed through long ice ages and long greenhouse periods. None of this paused to accommodate future humans. If you could stand on Earth 1 billion years ago, the planet would be almost unrecognizable. The continents were arranged differently. The atmosphere contained far less oxygen. The sun was dimmer. Days were shorter. Life existed, but not in familiar forms. There were no forests, no animals, no birdsong. Yet life was thriving in its own way, filling every available niche. Fast forward another few 100 million years, and still there is no sign of anything like human civilization. Plants eventually colonized land. Insects followed. Amphibians, reptiles, and later dinosaurs rose to dominance. For more than 150 million years, dinosaurs shaped terrestrial ecosystems. They were not a brief experiment. They were a long, stable chapter in Earth's story. During that entire time, mammals existed too, but mostly in the background. Small, adaptable, nocturnal. Waiting, not because the planet was waiting for them, but because ecological conditions favoured other forms. Then, through a combination of catastrophe and opportunity, the balance shifted. An asteroid impact, volcanic activity, climate disruption. Dinosaurs vanished and mammals diversified. Even then, intelligence as we define it did not immediately appear. Mammals explored many forms: size, speed, strength, specialization. Primates emerged relatively late, hominins later still. For most of mammalian history, brains remained modest relative to body size. Intelligence increased gradually, unevenly, shaped by environment and chance. Modern humans appeared only very recently, and even then it took tens of thousands of years for agriculture, cities, writing, and technology to develop. Civilization as we know it is not the default state of intelligent beings. It is a specific outcome of a very specific set of circumstances. All of this matters because it reframes our sense of centrality. Earth did not rush toward intelligence. It did not accelerate towards civilization. It spent billions of years exploring other possibilities. And during those billions of years, there was ample time for many things to happen, including things we may never know about. When people imagine earlier civilizations, they often picture something like humanity arriving too early, building cities among dinosaurs, then disappearing. That image is misleading. Earth's earlier eras were not static backdrops. They were complex, changing worlds with their own constraints and opportunities. A civilization arising millions of years ago would not look like a misplaced version of us. It would be shaped by a different atmosphere, different ecosystems, different energy flows. Even small differences matter. Oxygen levels, for example, have fluctuated dramatically over Earth's history. There were periods when oxygen concentrations were much higher than today, supporting giant insects and different fire regimes. There were periods when oxygen was lower, placing strict limits on metabolism and body size. These factors influence what kinds of organisms can exist, how active they can be, and how much energy they can devote to cognition. Day length has also changed. Hundreds of millions of years ago, days were shorter. Tidal interactions with the moon have gradually slowed Earth's rotation. That affects circadian rhythms, climate patterns, and biological timing. A civilization emerging under different day lengths would experience time differently at a fundamental level. Then there is climate stability. Human civilization developed during a relatively stable climatic window. The Holocene, the current interglacial period, has been unusually calm compared to much of Earth's past. Stable temperatures and predictable seasons made agriculture viable. That stability is not guaranteed. Many earlier periods were marked by extreme variability, rapid shifts, or prolonged inhospitable conditions. This suggests that civilization may be rare not because intelligence is rare, but because stable conditions are rare. If intelligence arises during turbulent periods, it may struggle to persist long enough to leave lasting traces. It may rise, adapt, and fall repeatedly, always constrained by environmental volatility. Earth has experienced at least 5 major mass extinctions, and many smaller ones. These events reshaped life dramatically, wiping out dominant groups and opening niches for others. From the planet's perspective, these are not anomalies. They are part of the process. Life rebounds, diversifies and continues, but continuity is not guaranteed for any particular lineage. If an intelligent species arose before one of these extinctions, its chances of long-term survival would depend on resilience, adaptability, and luck. A global catastrophe does not discriminate between technological sophistication and biological simplicity. It resets systems indiscriminately. There is also the matter of timescales for cultural transmission. Knowledge accumulates slowly and is easily lost. Writing, which allows knowledge to persist beyond individual lifespans, is a recent invention. Without durable recording systems, a civilization's accumulated understanding can vanish in a few generations if social structures collapse. Even with writing, continuity is fragile. Libraries burn, languages die, scripts become unreadable. We already struggle to interpret texts that are only a few thousand years old. Over millions of years, continuity without constant renewal is nearly impossible. So when we ask how long the Earth has been waiting before us, the more honest answer is that it hasn't been waiting at all. It has been running experiments. Some lasted a long time, some ended abruptly, some left traces we can still see. Many did not. This perspective does not require believing that an earlier civilization definitely existed. It simply acknowledges that Earth had both the time and the complexity to allow for many possibilities, and that absence of evidence over such spans is not surprising. It also challenges the idea that intelligence inevitably leads to permanence. Earth's history suggests the opposite. Most things, no matter how successful for a time, eventually give way to something else. Stability is temporary. Dominance is fleeting. Survival depends on constant adaptation. When you place humanity within this context, our story feels both extraordinary and precarious. Extraordinary because we are here at all thinking about these questions, capable of altering the planet and reflecting on its past. Precarious because nothing in Earth's history guarantees that this state will persist. The planet has endured far worse than anything we have yet caused. It has survived impacts, ice ages, and atmospheric transformations. It will likely survive us as well, regardless of what we do. The question is not whether Earth will continue, but what forms of life and intelligence will accompany it. In that sense, we are not the culmination of a long wait. We are one outcome among many, emerging at a particular moment under particular conditions. The Earth was not incomplete without us. It was different, and that realization shifts how we think about our place in time. It moves us away from the idea of destiny and toward the idea of participation. We are not the reason the story exists. We are part of it, briefly, contributing our chapter before the page turns again. Once you accept how long Earth existed before humans, how much happened without us, and how much time remains ahead, it becomes harder to insist that our presence defines the entire narrative. It also becomes harder to assume that nothing similar in some form could have happened before. When we talk about the past disappearing, it's tempting to imagine time itself as the culprit, as if years simply stack up and gently blur what came before. But time on its own doesn't erase much. What does the real work of forces that never stop moving? Erosion, ice, oceans. These are not background processes quietly ticking away. They are active, relentless systems that reshape the planet continuously, often with astonishing efficiency. If something once existed on Earth's surface and is no longer visible today, chances are high that one of these forces, or a combination of them, is responsible. Erosion is sometimes described as slow, but that description can be misleading. It is slow compared to a landslide or an explosion, but fast compared to the lifespan of civilizations and even species. Wind, rain, temperature changes, and chemical reactions work together to break down rock into smaller and smaller pieces. Water seeps into cracks, freezes, expands and splits stone apart. Roots grow into tiny fractures and pry them wider. Acids produced by plants and microbes dissolve, minerals grain by grain. Over centuries, structures soften. Over millennia, they flatten. Over longer spans, they disappear. Even the hardest rock does not win this contest forever. Mountains that once towered higher than today's Himalayas have been worn down to gentle hills or erased entirely. Ancient river valleys have been filled, carved again and filled once more. What looks permanent to us is often temporary from the planet's perspective. This matters because erosion does not discriminate. It does not preserve what is meaningful or important. It only responds to exposure. Anything left on the surface, no matter how deliberately built, begins to degrade the moment maintenance stops. Walls crumble, foundations crack, sharp edges round off. Eventually, the difference between something shaped intentionally and something shaped naturally becomes subtle enough to debate. Archaeologists already face this problem with sites that are only a few thousand years old. In regions with high rainfall or strong seasonal cycles, structures can erode almost beyond recognition in surprisingly short periods. Mud brick cities dissolve back into the ground. Stone structures lose their defining features. Without context, what remains can look like an ordinary hill or a scatter of rocks. Now extend erosion's reach across tens or hundreds of thousands of years. The effect compounds. Each cycle of weather removes a little more detail. Each biological interaction contributes to breakdown. Over deep time, erosion does not just damage structures, it erases the idea that there was ever structure there at all. Ice is even less forgiving. Glaciers are among the most powerful erasing forces on Earth. When massive ice sheets advance, they do not simply cover the land, they grind it. Embedded rocks act like sandpaper, scraping surfaces down to bedrock. Entire landscapes are flattened, valleys are widened, hills are shaved off. Anything that once existed on the surface in the path of a glacier is either pulverized or carried away. During the last ice age, large portions of North America, Europe and Asia were covered by thick ice sheets for tens of thousands of years. Any earlier surface evidence in those regions was effectively destroyed. Soil was stripped away, rocks were rearranged, debris was transported hundreds of kilometers and dropped elsewhere when the ice melted. If a civilization had existed in a glaciated region before an ice advance, its physical traces would almost certainly be gone, not buried neatly, not preserved under ice, actively destroyed. Buildings crushed, artifacts scattered or ground to fragments. The land itself resculpted so thoroughly that the previous surface became irretrievable. And ice ages are not rare events. Earth has experienced many glacial periods throughout its history. Some were more extensive than others, but all involved massive redistribution of material. The current interglacial period, the one in which human civilization developed, is relatively mild and unusually stable. It is the exception, not the rule. Even outside of full ice ages, localized glaciers have repeatedly advanced and retreated in mountainous regions. These cycles reset landscapes again and again. If something existed there between advances, it had little chance of survival. Then there are the oceans. Oceans are often imagined as preservers, gently covering things and keeping them safe. In reality, they are dynamic, destructive environments. Waves, currents, chemical corrosion, biological activity and sediment movement all contribute to breakdown. Objects submerged in seawater are subject to constant motion and chemical attack. Metals corrode rapidly. Wood is consumed by organisms. Structures collapse under pressure and instability. Sea levels have fluctuated dramatically over Earth's history. During ice ages, vast amounts of water are locked up in ice sheets, and sea levels drop by tens or even hundreds of meters. During warmer periods, ice melts and seas rise, flooding continental shelves. These shelves are not small areas. They make up large portions of Earth's surface, and have often been prime real estate for life due to shallow waters, nutrient availability, and stable temperatures. Many early human settlements were built along coastlines that are now underwater. We know this because we are close enough in time to detect them. Stone tools and structures have been found beneath the sea, preserved in sediment. But this preservation depends on timing and conditions. Over longer periods, underwater sites are not stable archives. Currents shift sediments. Storms disturb layers. Chemical processes alter materials. Over hundreds of thousands or millions of years, submerged landscapes do not remain intact. They are reworked repeatedly. Sediment layers are deposited, eroded, and redeposited. Tectonic processes can tilt, fracture, or subduct them. Anything built there is unlikely to remain recognizable. Now consider how these forces overlap. A structure built on a coastal plain might be eroded by wind and rain, flooded by rising seas, buried under sediment, exposed again by falling seas, scraped by ice, and finally altered chemically under pressure. Each stage removes information. By the end of that sequence, even the idea that something artificial once existed there may be impossible to reconstruct. This is not hypothetical. It is how Earth routinely operates. River systems add another layer of erasure. Rivers migrate. They carve new channels and abandon old ones. Floodplains are buried and rebuilt repeatedly. Entire settlements can be covered by meters of sediment in a single flood event. Over time, those sediments compact and become rock. If erosion later removes upper layers, the context is lost. Artifacts, if they survive at all, become isolated within geological layers, divorced from their original meaning. Volcanism contributes as well. Lava flows can bury landscapes under thick layers of rock. Ash falls can blanket regions, altering ecosystems and burying structures. While burial can sometimes preserve, volcanic environments are chemically aggressive. Heat alters materials, pressure deforms structures. Later tectonic activity can fracture and distort everything that was once sealed. And then there is biological erosion, which is often underestimated. life is remarkably good at dismantling structures. Microbes break down materials at the molecular level. Plants release acids that dissolve rock. Animals burrow, disturb layers, and redistribute materials. Coral reefs build and break down massive structures over time. Forests can dismantle stone foundations through root growth and chemical weathering. Over deep time, life does not just live on the planet, it actively reworks it. This matters deeply when considering why earlier civilizations, if they existed, might leave so little behind. The Earth is not neutral towards surface features, it actively removes them. And the longer the time span, the more thorough the removal. There is a tendency to imagine that something truly advanced would leave marks so obvious they could not be erased. But this assumption underestimates both the power of Earth's processes and the fragility of human-scale constructions. Even our most durable materials are designed to last centuries, not millions of years. Concrete, for example, feels permanent, yet it cracks, weathers, and reacts chemically with its environment. Over long periods, it breaks down into components that resemble natural stone. Steel corrodes, glass devitrifies, plastics fragment and chemically degrade. Remove the context, and what remains becomes increasingly ambiguous. Even nuclear waste, often cited as a long-term marker, decays. Its radioactivity diminishes. Containers corrode. Geological movement alters repositories. Over sufficiently long spans, even that signal fades. If future geologists encountered a thin layer enriched with unusual elements, they might interpret it as an environmental anomaly rather than evidence of intelligence. Without a clear pattern, interpretation remains uncertain. Earth's erasing forces are especially effective because they are not singular events. They are continuous. Erosion does not wait for catastrophes. Ice does not need permission to advance. Oceans do not pause to preserve history. They operate every day, every year, reshaping the surface incrementally until change becomes total. This is why deep time is so difficult for the human mind. We are accustomed to change happening on scales we can observe. Buildings collapse, shorelines retreat, glaciers melt. But we rarely experience the cumulative effect of these processes across the spans that geology considers routine. When you stretch the timeline far enough, the idea of permanent evidence becomes almost meaningless. This perspective also reframes how we think about gaps in the record. Missing evidence does not require extraordinary explanations. It is the expected outcome of ordinary processes given enough time. The default state of ancient surfaces is erasure, not preservation. In that light, the real surprise is not that we haven't found clear evidence of earlier civilizations, it's that we find as much as we do. Fossils are rare. Preserved sites are accidents. Each artifact that survives deep time does so because a specific sequence of events happened just right. Rapid burial, stable conditions, protection from disturbance. And even then, survival is not guaranteed. So when we look back across Earth's long history and see vast stretches that appear empty of intelligence, we must be careful not to confuse emptiness with absence. Those stretches may simply reflect the thoroughness with which erosion, ice, and oceans do their work. This does not mean that Earth's past is unknowable. It means that knowledge must be probabilistic, cautious, and humble. We infer from what remains, knowing that much did not. It also means that the story of civilization, including our own, is inseparable from the story of disappearance. Creation and erasure are not opposites on this planet. They are partners. As landscapes are built up, they are also worn down. As complexity emerges, it is also tested. What survives does so not because it deserves to, but because circumstances allowed it. Once this is understood, the idea of a silent past becomes less mysterious and more inevitable. Earth is very good at moving on. It does not archive, it recycles. And that realization leads naturally to a more personal reflection. If erosion, ice, and oceans erase so completely, then what we leave behind is not guaranteed to last. Our own civilization, no matter how advanced it feels now, is subject to the same forces, which raises the next question quietly in the background. If so much can be erased, if even intelligence can vanish without a trace, then what kinds of technologies, if any, would resist this process? What would have to be built, or perhaps avoided, to leave a signal that could cross deep time intact? When people imagine traces of advanced technology in the distant past, they usually picture something solid and unmistakable. Metal machines locked in stone, power plants frozen in time, devices so clearly artificial that no geological process could disguise them. It's a comforting image because it reassures us that if something sophisticated had existed before, we would surely know. The evidence would be obvious, impossible to miss, waiting patiently to be discovered. But the confidence rests on a misunderstanding of both technology and fossilization. Fossils are not a record of importance or intelligence. They're a record of durability under very specific conditions. And most technologies, including our own, are not designed with geological endurance in mind. They are designed for performance, efficiency, adaptability, and replacement. Longevity, beyond a few decades or centuries, is rarely a priority. When those priorities collide with deep time, technology loses almost every time. To see this clearly, it helps to think about what fossilization actually preserves. Fossils form when materials are buried quickly, protected from oxygen, scavengers and chemical breakdown, and then slowly mineralized. Hard tissues like bone and shell sometimes qualify. Most manufactured objects do not. They either decay too quickly, react chemically, or fragment into components that blend back into natural systems. Take electronics, for example. Modern civilization is defined more by information processing than by heavy machinery. Computers, sensors, communication networks, satellites. These systems rely on delicate arrangements of materials at microscopic scales. Silicon wafers, copper traces, rare earth elements, polymers. Exposed to moisture, heat, and oxygen, these components degrade rapidly. Circuit boards corrode, plastics embrittle and fragment, insulation breaks down. Without constant maintenance, most electronics fail within years. Buried in soil, they fare even worse. Even if fragments survived long enough to be buried, their structure would not remain intact. Over time, metals dissolve and migrate. Polymers break into smaller molecules. Glass devitrifies and loses its clarity. The original function becomes impossible to infer. What remains is chemistry, not machinery. Now consider energy systems. Power generation feels like something that should leave a mark. But most forms of energy use leave surprisingly little behind. Electricity itself leaves no fossil. Light, heat, sound, electromagnetic waves. None of these are preserved in rock. They are experiences, not artifacts. Fossil fuels do leave residues, but those residues are ambiguous. Ash layers, soot, carbon enrichment. These can result from natural fires, volcanic activity, or biological processes. Distinguishing industrial combustion from natural events millions of years later would be extraordinarily difficult unless the signal were both global and extreme. Even then, interpretation would be cautious. Earth has experienced many episodes of rapid carbon release and climate change without any intelligent cause. Large igneous provinces, methane clathrate releases, asteroid impacts. The planet does not need technology to disrupt itself. Renewable energy systems fare no better in the fossil record. Wind turbines collapse and rust. Solar panels degrade chemically and physically. Hydroelectric dams erode, fracture, and are eventually dismantled by rivers. Given enough time, these structures break down into materials that resemble natural rock and sediment. Transportation technologies are similarly fragile. Vehicles are complex assemblies of metal, rubber, plastic, and electronics. Abandoned, they decay quickly. Within centuries, they are unrecognizable. Roads crack, erode, and are reclaimed by vegetation. Asphalt oxidizes and breaks apart. Rail lines rust and sink into the ground. Remove maintenance, and mobility vanishes without a trace. Aviation and space technology feel more permanent, but they are not. Aircraft are lightweight by design. They corrode, fatigue, and fail. Satellites orbit temporarily and then burn up or crash. Space debris may linger in orbit for a while, but over long spans, orbital decay and collisions remove it. Nothing stays aloft forever. Even massive industrial complexes are not safe. Factories collapse, machinery rusts, chemical residues disperse. Over geological timescales, the difference between an abandoned industrial site and a natural mineral deposit becomes increasingly subtle. There is also the question of scale. Fossilization favours abundance and repetition. A single object, no matter how advanced, is unlikely to survive. Large numbers increase the odds, but only slightly. And if a civilization did not blanket the planet with identical structures, its footprint would be scattered and vulnerable. Now imagine a technological pathway that minimizes material accumulation. A civilization that prioritizes efficiency and recycling. One that designs systems to break down cleanly when no longer needed. One that avoids large static infrastructure in favor of flexible, adaptive systems. Such a civilization would be technologically sophisticated, yet archaeologically quiet. Biotechnology is a good example. If technology is embedded in living systems, it leaves almost no trace once those systems die. Engineered organisms decay like any others. Genetic modifications do not fossilize as technology. DNA breaks down. Proteins denature. After enough time, even the fact that something was engineered becomes indistinguishable from natural variation. Chemical technologies pose a similar challenge. Many advanced processes rely on catalysts, solvents, and reactions that leave no durable residue. Once the process stops, the chemicals dissipate or react further. Without context, there is nothing to point to intentional design. Information-based technologies are even more elusive. Software, algorithms, data storage. These define modern civilization more than steel and concrete. But information without a medium does not exist physically. And most media are fragile. Magnetic storage demagnetizes. Optical storage degrades. Solid-state memory fails. Paper rots. Ink fades. Stone inscriptions last longer. But they are inefficient for large-scale information storage and increasingly unnecessary as technology advances. A civilization that mastered information processing without relying on permanent physical records would leave almost nothing behind once its population vanished. There is also a deeper assumption worth questioning. We often assume that technological progress must move toward increasing material complexity and environmental impact. But that trajectory is not inevitable. It reflects a particular set of constraints and values: energy availability, population pressure, competition. Under different conditions, progress might look like refinement rather than expansion. A technologically mature civilization might deliberately move away from heavy industry. It might favour low-impact systems that integrate seamlessly with natural cycles. It might even view large, permanent structures as liabilities rather than achievements. In that case, its technological peak would coincide with its lowest archaeological visibility. Time adds another layer of erasure. Even if some technologies left unusual traces, recognizing them as technological requires context. A fragment of alloy embedded in rock might be dismissed as a natural inclusion. Anomalous isotope ratios might be attributed to volcanic processes. Without a clear pattern, interpretation remains uncertain. We already see this problem in geology. Some mineral formations once thought to be biological are now understood as purely chemical. Others went the opposite direction. Interpretation shifts as understanding improves. Over deep time, ambiguity dominates. It's also important to remember that fossilization is not uniform across environments. Technologies used primarily in the atmosphere Oceans or biosphere are especially unlikely to fossilize. Atmospheric manipulation leaves transient effects. Ocean-based systems are reworked continuously by currents and chemistry. Biological systems decay rapidly. Even large-scale environmental modification might not leave a clear technological signature. Climate shifts can result from many natural causes. Ecosystem changes can follow volcanic events or asteroid impacts. Without a smoking gun, attribution is speculative. This brings us to an uncomfortable realization. The technologies most likely to fossilize are those that are crude, inefficient, and environmentally disruptive. Heavy mining, massive waste accumulation, widespread pollution, large-scale extinction events. These leave sharp global signals. Cleaner, more refined technologies leave softer footprints that blend into background noise. In that sense, archaeological visibility may be inversely related to sustainability. The more a civilization damages its environment, the more likely it is to be noticed in the deep future. The more harmoniously it operates, the easier it is for time to erase. This does not mean that earlier civilizations must have been perfectly sustainable to be invisible. It only means that invisibility is not evidence of absence. It is the expected outcome for many plausible technological pathways. We often ask why we don't find ancient machines or power plants. A better question might be why we expect to. Our own most important technologies would leave almost nothing recognizable if stripped of context and given enough time. If humanity disappeared today and Earth continued for another 100 million years, future observers might struggle to identify our technological era with certainty. They might notice a brief spike in certain elements, a thin layer marking rapid change, perhaps an extinction boundary. Beyond that, interpretation would be cautious. They would not find smartphones. They would not find servers. They would not find cities in any meaningful sense. Those things would be gone. So when we imagine technologies that wouldn't fossilize, we're not stretching our imagination beyond reason. We are simply taking seriously how fragile technology really is when removed from maintenance and compressed under geological time. Technology exists to be used, not preserved. It assumes a living society to support it. Without that support, it decays faster than stone tools ever did. This perspective reframes the entire question of earlier civilizations. It suggests that the absence of fossilized technology tells us very little about whether technology existed. It tells us only that fossilization is an exceptionally poor witness to technological sophistication. And that realization naturally leads to another shift in thinking. If material traces are unreliable, then perhaps the best evidence of earlier civilizations would not be objects at all, but subtle, indirect changes. Changes in chemistry, changes in biology, changes in planetary systems that persist long after the tools themselves are gone. Those kinds of signals are harder to detect, harder to interpret, and easier to misattribute. But they may be the only ones capable of crossing the immense gulf of deep time. Which means that when we look for the past, we may need to stop asking where the machines are and start asking how the planet itself might carry faint memories of intelligence that once moved through it, briefly, quietly, and then disappeared back into the flow of Earth's long, restless history. Long before written records, before dates were carved into stone or events pinned to calendars, people told stories. They told them around fires, during long walks, while watching the sky change colour at dusk. These stories were not meant to preserve exact facts in the way modern history tries to. They were meant to carry meaning, memory, and warning. Over time, many of those stories hardened into myths, and while myths are often treated as fiction, they are rarely invented from nothing. Across cultures that never met, separated by oceans and thousands of years, certain themes appear again and again. Great floods that wipe away earlier worlds, advanced ages that end suddenly, wise beings who vanish, humanity restarting after catastrophe. These stories are so widespread that they can feel uncanny, as if many people were remembering something similar through different lenses. The flood story is the most famous example. Versions of it appear in Mesopotamia, India, China, the Americas, Africa and Oceania. Sometimes the flood is sent by angry gods. Sometimes it is a natural correction. Sometimes it is accidental. But the structure remains remarkably consistent. An earlier world exists. It is destroyed by water. A few survive. The world begins again, diminished, changed, forgetful of what came before. From a scientific perspective, floods are common. At the end of the last ice age, melting glaciers caused sea levels to rise rapidly. Coastal regions were submerged. Entire landscapes disappeared underwater. Human populations were displaced, sometimes catastrophically. Oral traditions could easily preserve memories of such events, passed down and reshaped over generations. But the sheer number and persistence of these stories raise another possibility. Not that myths are literal historical records, but that they may be echoes of repeated disruptions, layered on top of one another. Each retelling compresses time. Different events blend together. What remains is not a timeline, but a pattern, and patterns matter. When myths describe a previous age that was more advanced, more ordered, or more connected to the natural world, they are often dismissed as nostalgia or symbolism, a golden age that never really existed. But it's worth asking why this idea appears so consistently. Why do so many cultures imagine that the past held something lost, rather than the future holding something yet to come? Part of the answer may lie in how memory works. Trauma compresses. Large-scale disasters leave deep impressions. When environments change rapidly, societies reorganize. Knowledge can be lost. Skills that were once useful become irrelevant. Over generations, what was once practical becomes mythic. Imagine a coastal society with sophisticated navigation, trade networks, and environmental knowledge. If rising seas forced that society inland, much of its expertise would no longer apply. Boats become useless. Coastal landmarks disappear. Trade routes collapse. Within a few generations, the reasons behind old practices are forgotten, but the stories remain. Tales of a drowned world, of ancestors who lived differently, of a time before the waters rose. Now imagine this happening not once, but many times across deep history. Floods are not the only recurring motif. Myths often speak of fire from the sky, of the sun behaving strangely, of long winters, of sudden darkness. These descriptions align uncomfortably well with known natural events. Volcanic eruptions that blot out the sun, asteroid impacts that ignite wildfires, abrupt climate shifts that plunge regions into cold or drought. Again, science explains these phenomena without invoking lost civilizations. But explanation does not erase impact. For people living through such events, the experience would be world-ending. Everything familiar would fail at once. Survival would become the only priority. Knowledge not directly tied to survival would vanish quickly. In such circumstances, even a technologically capable society could regress dramatically. Infrastructure would fail without maintenance. Specialized skills would disappear as experts died or dispersed. Writing systems could be lost if materials became scarce or literacy declined. Within a surprisingly short time, a complex society could fragment into smaller, simpler groups. Archaeology already documents this process within recorded history. The collapse of the Bronze Age saw widespread loss of writing, trade, and urban life across large regions. The Roman Empire's decline in the West led to centuries where literacy and infrastructure were dramatically reduced. These collapses occurred over decades and centuries, not millennia. Now scale that process up. Add a global or near-global disruption. Remove the safety net of neighbouring civilizations. Stretch the recovery period across thousands of years. The resulting loss would be profound. Myths, in this light, become compressed memories of disruption. Not precise accounts, but emotional and structural ones. They remember that something existed before, that it ended badly, that survivors were fewer, that the world afterward felt different. Some myths go further. They speak of beings who taught humanity essential skills, then vanished. Agriculture, architecture, astronomy, law. These figures are often portrayed as gods or semi-divine ancestors. From a literal standpoint, this is mythology, but from a functional standpoint, it reflects a memory of a knowledge transfer that later generations no longer fully understood. If a society inherited fragments of knowledge without the context to explain them, myth would be a natural container. Stories preserve what explanations cannot. They keep the shape of an idea even when its details are lost. This does not mean that myths prove the existence of earlier civilizations. It means they point to something else that is easy to overlook. Human memory extends beyond material evidence. It operates through narrative, symbolism, and repetition. It can preserve impressions long after facts are gone, and myths are resilient. Unlike buildings, they do not erode easily. They adapt, they migrate, they attach themselves to new places and new names. A flood story told in one region may shift location when people migrate. Mountains change, rivers change, but the structure of the story remains. This adaptability makes myths unreliable as historical documents, but extremely reliable as indicators of recurring experiences. There is also an important asymmetry in how myths are treated. When a myth aligns with known events, such as a local flood or eruption, it is often reinterpreted as a memory of that event. When it does not align neatly, it is dismissed as pure fiction. Rarely do we ask whether multiple events, layered over time, could produce a story that no single event fully explains. The idea of forgotten worlds fits uncomfortably into this gap. Not as literal lost continents or vanished empires with advanced machines, but as cycles of rise, disruption, and loss that repeat often enough to leave cultural scars. Even the concept of ages found in many mythologies reflects this cyclical thinking. Ages of creation, decline, destruction, renewal. These are not linear progress narratives, they are rhythms. They imply that what exists now is not the first, and will not be the last. Modern historical thinking prefers linearity. Progress from simple to complex, from ignorance to knowledge, from past to future. This framework has been enormously useful, but it is not the only way to understand time, and it may not be the best way to understand deep time. In deep time, cycles dominate. Climate cycles, geological cycles, biological cycles, extinction and radiation, stability and disruption. There is no guarantee that complexity accumulates smoothly. It can spike, collapse, and re-emerge in new forms. Myths may be the human expression of a living within those cycles without the benefit of long-term records. Another recurring feature of myths is moral framing. Catastrophes are often explained as punishment or correction. From a modern perspective, this feels naive, but moral framing serves a purpose. It encodes caution. It warns against hubris, imbalance, or ignoring limits. Whether or not the original catastrophe had moral causes, the lesson survives. If earlier societies collapsed due to environmental mismanagement, resource depletion, or social instability, those lessons might survive only as stories of divine anger or cosmic reset. Over time, causes blur. Consequences remain. Flood myths, in particular, may carry warnings about living too close to rising waters, about respecting cycles, about the danger of assuming permanence in unstable environments. These warnings remain relevant long after their original context is forgotten. There is also a quieter aspect to these stories. Many are not with triumph, but with survival. A small group endures, they rebuild. But something is missing. The world afterward is not the same as before. This sense of loss permeates many traditions. That feeling is important. It suggests that myths are not just origin stories, but aftermath stories. They are told by people who feel they are living in the shadow of something greater that came before, even if they cannot name it clearly. In that sense, myths may be less about glorifying the past and more about explaining why the present feels diminished. This interpretation becomes more compelling when you consider how easily knowledge can be lost. Even today, with global communication, specialized knowledge is fragile. It depends on education systems, economic stability, and infrastructure. Disrupt those systems long enough and expertise evaporates. Now imagine a world without digital backups, without printing, without standardized education. Knowledge would reside almost entirely in people. When people die, knowledge dies with them unless it is actively passed on. Catastrophe accelerates that loss dramatically. In such a world, it would not take long for advanced understanding to become mythic. Techniques become rituals, explanations become stories. Eventually, even the stories degrade. From this perspective, myths are not evidence of fantasy, but evidence of forgetting. They mark the places where memory thins, where history transitions into something softer, less precise, but still emotionally true. And because myths are shaped by the concerns of the present as much as by memories of the past, they are constantly reinterpreted. Each generation finds new meaning in them. That makes them poor tools for reconstructing exact events, but powerful indicators of recurring human experiences. Floods, collapse, renewal, loss of knowledge. These are not rare in Earth's history. They are expected outcomes of living on a dynamic planet. So when myths speak of forgotten worlds, it may be less about specific lost civilizations and more about the recognition that worlds can end, that ways of life can disappear so completely that only stories remain. That continuity is fragile. This does not require believing that humanity inherited myths from a technologically advanced precursor species. It only requires acknowledging that memory stretches further than material evidence, and that deep disruptions leave impressions that persist even when details vanish. It also requires humility. The humility to accept that our own civilization is not immune to the same processes. That future generations, if they exist at all, may tell stories about us that bear little resemblance to what actually happened. That our technologies may become legends. That our failures may be moralized. That our world may be remembered as something that existed before the waters rose, or the climate shifted, or the systems failed. Myths are not reliable witnesses in the courtroom of history, but they are honest witnesses of how it feels to live through loss and change. They tell us that humans again and again have sensed that something came before, something ended, and something fragile replaced it. And when you place those stories alongside the immense age of the Earth, alongside the cycles of erosion, ice, oceans, and technological fragility, they stop feeling like idle fantasy. They start to feel like the cultural sediment left behind by repeated encounters with impermanence. The echoes they carry are not blueprints or maps. They are impressions, warnings, emotional truths passed down because nothing else survived. Unlike myths, which speak in symbols and stories, the geological record speaks in absence as much as presence. It is a ledger written in rock, sediment, and chemistry, and one of its most striking features is not what it contains, but what it does not. Vast stretches of time are missing entirely. Millions of years vanish between layers. Entire surfaces are erased, replaced, overwritten, or never preserved at all. This silence is not an anomaly. It is the default condition of deep time. When people imagine the geological record, they often picture a neat stack of layers, each one representing a chapter in Earth's history, patiently waiting to be read. In practice, that image is deeply misleading. Real geology looks more like a book that has been dropped into a river, dried out, torn apart, and partially burned. Some pages survive, others are gone, many are out of order, and large sections are missing without explanation. Geologists even have a name for this missing time. They call it unconformity. An unconformity represents a gap in the geological record where deposition stopped, erosion removed existing layers, or both. These gaps can span thousands, millions, or even hundreds of millions of years. Nothing about the rocks themselves tells you what happened during that time. They only tell you that whatever was there is gone. Some unconformities are so large they are hard to emotionally process. The Great Unconformity, for example, represents a gap of over 1 billion years in some locations. In those places, ancient crystalline rock sits directly beneath much younger sedimentary layers, with almost nothing preserved in between. 1 billion years of Earth's history is simply missing. Entire eras of tectonic movement, climate shifts, biological evolution, and surface activity have been erased. This alone should make us cautious about declaring what did or did not happen in deep time. The silence in the geological record is not evenly distributed. Certain environments preserve information better than others. Calm, shallow seas with steady sedimentation are excellent record keepers. Rapid burial under fine sediments can preserve detail. In contrast, uplands, coastlines, river valleys, and tectonically active regions are poor archivists. They are places of erosion, movement, and disruption. Unfortunately for historians of civilization, these poor archivists are precisely where complex life is most likely to thrive. Land surfaces, coastlines, river deltas, and resource-rich regions are attractive places to live. They are also the places least likely to preserve long-term records. This creates a fundamental asymmetry. The geological record is best at preserving the deep ocean and worst at preserving the places where civilizations would most plausibly exist. When we search for ancient life, we often look in sedimentary rocks laid down in marine environments. That's where fossils are most abundant. But if an intelligent civilization arose primarily on land, especially in dynamic environments, its chances of being preserved are dramatically lower. The absence of evidence in marine sediments tells us very little about what may have happened on continents that were later eroded, submerged, or recycled. Plate tectonics makes this problem worse. Earth is unique among known rocky planets in having active plate tectonics. This process is essential for long-term climate stability and biological diversity, but it is terrible for preservation. Oceanic crust is constantly being destroyed. Continental crust is deformed, fractured, and reworked. Entire regions are subducted into the mantle and lost forever. Most of Earth's surface from deep time no longer exists. It has been physically removed from the planet's exterior. Any traces it carried are unrecoverable. No technology, no excavation, no clever analysis can retrieve information that has been melted into magma. This means that the further back you go, the more biased your sample becomes toward rare, stable fragments of crust that happen to survive. These fragments are not representative of the planet as a whole. They are survivors, not averages. Even within surviving crust, preservation is selective. Sediments must accumulate faster than erosion removes them. Conditions must remain relatively stable. Chemical environments must be favourable. Disruptions must be limited. This combination is rare and it rarely lasts long. As a result, the geological record is not a continuous movie. It is a collection of still frames, many of them damaged, most of them incomplete, separated by long stretches of missing footage. Now consider what this implies for detecting past civilizations. Civilizations, by definition, operate on the surface. They build on land. They modify environments that are already geologically active. They exist during periods that may be brief compared to geological timescales. Even a civilization that lasted tens of thousands of years would occupy a vanishingly small slice of deep time. If such a civilization happened to exist during a period later erased by erosion or tectonics, it would leave no trace at all, not hidden, not buried, simply gone. And even if traces were preserved somewhere, they would need to be recognized as artificial. That recognition depends on context. A single anomalous layer or structure stripped of surrounding information may be interpreted as a natural oddity. Geology is full of strange formations produced by non-intentional processes. This is already a challenge when interpreting the ancient past. Certain formations once thought to be evidence of early life were later reclassified as abiotic structures. Others went the opposite direction. Interpretation changes as understanding evolves. Ambiguity is unavoidable. The silence in the geological record is therefore not neutral. It actively shapes our confidence. When we do not see something, we tend to assume it was not there. But in geology, absence often means erasure, not non-existence. This creates a subtle cognitive trap. We mistake the limits of preservation for limits of possibility. It is also important to recognise that geology records certain kinds of events far better than others. Large-scale volcanic eruptions leave thick ash layers. Massive impacts leave global signatures. Rapid climate shifts leave isotopic signals. These events are loud. They leave planet-wide markers that persist. Human-scale activity is quiet by comparison. Even our most dramatic interventions barely register geologically unless they are global and extreme. A civilization that never triggered a massive extinction or left behind large volumes of unusual material might leave no clear signal at all. This means that the geological record is biased toward catastrophe. It remembers disruption better than organization. It records collapse more clearly than stability. A civilization that ended abruptly in a catastrophic event might leave a clearer signal than one that faded gradually. Ironically, this suggests that the most visible civilizations in deep time would be the least successful ones, those that destabilize their environment enough to leave a lasting scar. Silence in this context may indicate moderation, integration, or simple bad luck in preservation. There is also a temporal resolution problem. Geological dating methods are powerful, but they are not infinitely precise. Radiometric dating often comes with uncertainties of thousands or millions of years. Sedimentary layers can represent long periods of slow accumulation. Events that happen quickly relative to those scales are blurred. A civilization that rose and fell within a few thousand years could be smeared into a single layer or missed entirely. Its duration might be shorter than the resolution of the record that contains it. Even chemical signatures can be ambiguous. Changes in carbon isotopes, for example, can indicate biological activity, climate change, or industrial processes. Distinguishing among these requires context and corroborating evidence. Without that, interpretation remains tentative. This is why scientists approach claims of ancient civilizations with caution, not because the idea is inherently absurd, but because the evidence threshold must be high to overcome the ambiguity imposed by deep time. Extraordinary claims require extraordinary evidence, but extraordinary evidence is precisely what deep time makes rare. Yet caution should not harden into certainty in the opposite direction. Declaring that something did not happen because we do not see it assumes that the record is complete enough to support that claim. In geology, completeness is rare. The silence in the geological record is not a blank page, it is a heavily edited one. Every unconformity, every missing layer, every eroded surface represents lost information. We know it is lost, we just do not know what it contained. That ignorance should temper confidence, not fuel speculation, but it should also keep questions open. This perspective aligns with what geologists themselves emphasize. They do not claim to have a full record. They work with fragments, correlations, probabilities. Models are built, tested, revised. Certainty is provisional. When popular narratives flatten this nuance into a clean story of uninterrupted progress, they obscure how much uncertainty remains. And this uncertainty grows as we look further back. The early Earth is especially poorly recorded. Rocks from the first half of Earth's history are rare and heavily altered. Whatever happened on the surface during that time is mostly unrecoverable. This includes not just potential civilizations, but vast stretches of biological evolution we will never fully reconstruct. Entire ecosystems may have existed without leaving recognizable fossils. Entire evolutionary pathways may have been tried and abandoned. The geological record does not deny this. It quietly admits it through its gaps. So when we confront the silence, the question is not whether it hides something specific, but what it tells us about our limits. It tells us that Earth's memory is incomplete, that preservation is selective, That absence of evidence is not a strong form of evidence in deep time. It also tells us something about ourselves. We crave definitive answers. We want to know if we are first, unique, destined. The geological record does not provide that reassurance. It offers something less comforting but more honest. A reminder that the planet is older, busier and more forgetful than we often assume. And that forgetfulness is not malicious. It is mechanical. It arises from the same processes that make Earth habitable in the first place. Plate tectonics regulates climate. Erosion creates fertile soils. Oceans recycle nutrients. Ice reshapes landscapes. The price of a living planet is a poor memory. If Earth were better at preserving its surface, it might not support life as we know it. The very processes that erase history are the ones that sustain the present. This brings us to a quiet crossroads in the story. If the geological record is silent not because nothing happened, but because so much was erased, then we are left with a humbling uncertainty. We may never know whether earlier civilizations existed, not because the question is meaningless, but because the evidence may be gone. What we can know is that the planet does not guarantee remembrance, that significance does not correlate with survival, that even entire worlds can vanish without leaving a clear trace. Strip away the familiarity of the present for a moment and imagine a quieter Earth. No engines, no lights at night, no voices carried across cities. The planet continues without interruption, not dramatically, not angrily, but indifferently. Rain still falls. Plants grow through cracks. Rivers change course. Seasons cycle. Now ask the question slowly, without urgency or drama. If we disappeared entirely, not tomorrow but completely, what would actually remain of us after deep time has done its work? It's a surprisingly difficult question to answer honestly, because so much of what feels permanent in daily life is only stable because we actively maintain it. Roads are repaired, buildings are reinforced, power grids are monitored, data is backed up. Remove human attention, and decay begins immediately. Entropy does not wait. In the first few decades after disappearance, the signs of humanity would still be obvious. Cities would stand, though increasingly unstable. Windows would break. Roofs would collapse under weather stress. Plants would reclaim sidewalks and interiors. Animals would move in. This phase is easy to picture because it operates on timescales we understand. But geology does not care about decades. It barely notices centuries. Within a few hundred years, most wooden structures would be gone entirely. Steel-reinforced buildings would weaken as metal corrodes and concrete cracks. Bridges would fail. Dams would eventually breach, either through erosion or seismic activity. Rivers would flood old valleys. Coastal cities would begin to crumble into the sea. A few thousand years later, the surface story would already be difficult to read. Stone structures might persist in fragments, but without context. Quarries would soften. Roads would fragment into oddly straight gravel deposits. Agricultural fields would be hard to distinguish from natural clearings. Without written records or living memory, interpretation would already be speculative. What often surprises people is how little of our technological civilization is built to last even that long. Modern materials prioritize efficiency and cost, not endurance. Glass shatters. Plastics degrade under ultraviolet light, heat, and chemical exposure. Metals corrode. Composite materials delaminate. Electronics fail quickly once exposed to moisture and temperature fluctuations. Digital civilization, which feels so expansive and permanent while active, would vanish almost immediately. Data requires energy, cooling, and upkeep. Servers would shut down within days. Cloud storage would not float on its own. Magnetic storage would degrade. Solid-state memory would fail. Within a century, almost all digital information would be gone beyond recovery. Libraries would not fare much better. Paper decays. Ink fades. Fires and floods destroy archives easily. Even stone inscriptions, unless carved deeply and preserved under favourable conditions, weather away. The idea that future beings would simply read our history assumes continuity that deep time does not provide. As tens of thousands of years pass, the situation becomes more stark. Ice ages could return. Glaciers could advance over large portions of the continents. Anything in their path would be scraped away or pulverized. Sea levels could rise or fall dramatically, submerging or exposing vast regions. Coastlines, where many of our largest cities exist, are among the least stable environments on Earth. Over hundreds of thousands of years, tectonic processes begin to dominate. Regions uplift, others sink, sediments bury surfaces, old river channels are erased, volcanic activity blankets landscapes in lava and ash. What remains of human construction is increasingly buried, distorted, or destroyed. At this point, what would actually be detectable? There might be a thin geological layer marking an abrupt change, an unusual spike in certain elements, elevated concentrations of plastics broken down into microscale residues, altered isotope ratios from fossil fuel combustion, a brief but sharp extinction event where many species vanish rapidly. These are not buildings or tools, they're indirect signals, subtle and open to interpretation. Future geologists, if they existed, might notice this layer and debate its cause. Was it volcanic? Was it climatic? Was it biological? Without additional context, identifying intelligence as the cause would be challenging. Earth has produced similar signatures on its own many times. Some structures might survive longer than others. Large stone monuments in stable environments could persist in fragmentary form. Underground spaces such as tunnels or mines might last longer if not collapsed. But even these are not guaranteed. Water infiltrates, rock shifts, chemical processes continue. Given enough time, they too disappear. Nuclear waste is often mentioned as something that would persist far into the future. It does, but not in the way people imagine. Radioactive materials decay. Containers corrode. Geological repositories are chosen precisely because they are stable, but stability is relative. Over hundreds of thousands or millions of years, even these sites will change. The radiation signal diminishes. Without labels that can be understood, even this becomes just another unusual mineral occurrence. Satellites and space debris might seem like lasting markers, but they are transient. Orbits decay, collisions occur, atmospheric drag eventually brings objects down. Over long periods, Earth's orbital environment clears itself. Perhaps the most enduring legacy of humanity would not be physical at all, but biological. Domesticated species spread far beyond their original ranges. Invasive species introduced intentionally or accidentally reshape ecosystems. Genetic signatures of selective breeding persist. Some species flourish because of us, others vanish because of us. Future biologists might notice abrupt changes in species distribution and diversity. They might infer the presence of an unusual selective pressure. Whether they would identify it as intelligence depends on their framework and the resolution of their data. It is entirely possible that humanity's most lasting mark would be a rearrangement of life rather than a collection of artifacts. This realization is unsettling because it undermines a common assumption. We tend to believe that significance ensures remembrance, that if something matters enough, it will leave a clear trace. Deep time does not operate that way. It preserves accidents, not intentions. The question then becomes less about what we hope would remain, and more about what realistically could. If we vanished quietly, without triggering a massive global catastrophe, our physical footprint would fade quickly. If we vanished violently, the signal would be stronger but also less flattering. The planet would remember the damage, not the culture. In that sense, the way a civilization ends may determine how visible it becomes in the deep future. Collapse without collapse, decline without explosion. These are archaeologically quiet outcomes. And that brings the question back around to earlier civilizations. If we struggle to imagine our own lasting clearly beyond a few million years, Why assume that anything earlier would be obvious to us now? This thought experiment also forces a re-evaluation of how we measure success. Longevity feels like a natural metric, but longevity of what? Structures, materials, influence? Earth's history suggests that biological impact lasts longer than architectural achievement. Chemical changes outlast political systems. Ecosystem shifts persist longer than monuments. From that perspective, our legacy is already being written, regardless of what happens next. The planet is responding. Species are adapting or disappearing. Climate systems are adjusting. These changes will echo forward whether or not we remain to observe them. What is striking is how small the window of visibility really is. There is a brief span of time where a civilization is active and obvious. Before that, it is emerging. After that, it is dissolving. Outside that window, interpretation becomes guesswork. We often imagine future intelligence looking back and clearly seeing us as a distinct era, neatly labelled and understood. That assumption flatters us. The reality is likely far messier. Our presence would be inferred indirectly, debated, revised, and possibly misunderstood. Just as we debate ambiguous traces in our own deep past, future observers would debate us. And if that is true, then the absence of obvious earlier civilizations becomes less mysterious. It may simply reflect the same process we are already part of. Emergence, activity, disappearance, erasure. Earth does not build museums. It builds layers, and then it reworks them. This perspective does not diminish the importance of human experience. It reframes it. Our stories, our knowledge, our relationships matter intensely while we are here. They just do not automatically translate into geological permanence. Understanding that can feel sobering, but it can also be clarifying. It shifts attention away from being remembered and toward being responsible. If nothing we build is guaranteed to last, then the value of what we do lies in its effect on living systems now and in the near future. And it brings us back to the larger theme quietly threading through this entire discussion. Civilization is not a static achievement. It is a process, one that exists for a time under certain conditions and then changes or ends. If earlier civilizations existed, their disappearance would not require mystery or conspiracy. It would require only time and an active planet. Looking at our own likely fate in the geological record makes that possibility feel less speculative and more ordinary. Not inevitable, but plausible. Rather than unfolding as a straight ascent from simplicity to sophistication, intelligence may behave more like a wave. It rises under certain conditions, crests for a time, and then falls back, reshaped by forces larger than itself. This way of thinking is less comforting than a progress narrative, but it aligns more closely with what we see when we step back and look at Earth's history without placing ourselves at the centre. Cycles are everywhere on this planet. Climate cycles, carbon cycles, tectonic cycles, extinction and recovery. Nothing moves in only one direction for very long. Stability is temporary, change is constant. Against that backdrop, it would be unusual if intelligence, once it appears, were exempt from the same pattern. When we talk about intelligence here, it's important to be precise. Intelligence is not a single trait. It is a collection of capacities. Problem solving, abstraction, social coordination, communication, learning, tool use. These traits appear in many species to varying degrees. What we call advanced intelligence is simply a dense clustering of these capacities, reinforced by culture and cumulative knowledge. Culture, however, is fragile. Biological evolution moves slowly. Cultural evolution can move quickly, but it can also reverse quickly. Knowledge accumulates over generations, but it depends on social continuity. Disrupt that continuity and intelligence does not disappear, but its expression changes dramatically. We already have clear examples of this within human history. Societies rise to remarkable levels of organization, technology, and knowledge, only to decline or collapse under pressure. The reasons vary. environmental stress, resource depletion, internal conflict, external invasion, disease. Often, it is not one cause but many interacting at once. What follows collapse is rarely total extinction. People survive, intelligence remains, but the complexity that allowed large-scale coordination and specialization breaks down. Skills are lost, networks fragment, knowledge that once required institutions to maintain disappears. The key point is that collapse does not reset intelligence to zero. It resets expression. This distinction matters when considering deep time. If intelligence arises earlier than we think, it does not need to vanish completely to become invisible. It only needs to lose the structures that sustain its complex expressions. Imagine a species capable of advanced reasoning, tool use, and social organization, living in a world with limited environmental stability. It might develop technologies suited to its time. It might build systems of knowledge and culture. But if conditions shift faster than those systems can adapt, collapse becomes likely. And Earth is very good at shifting conditions. Climate can change abruptly. Ocean currents can reorganize. Volcanic activity can darken skies for years. Asteroid impacts can alter global ecosystems overnight. Even slower changes like continental drift or long-term cooling can undermine established ways of life. In such an environment, intelligence might arise multiple times, each time reaching a certain level before encountering limits imposed by instability. This idea challenges the assumption that once intelligence appears, it naturally accumulates and persists. That assumption is rooted in our recent experience, during a relatively stable climatic window. It may not hold across Earth's full history. Consider how narrow the window for modern human civilization actually is. Agriculture depends on predictable seasons. Cities depend on surplus food and stable trade routes. Writing depends on materials and institutions. Science depends on cumulative records and long-term investment. Remove any of these supports for long enough, and complexity erodes. Now imagine this process playing out over millions of years, not just once, but repeatedly. A cycle might look like this. Environmental conditions stabilize for a period. Life diversifies. Intelligence reaches a threshold where culture and technology begin to accumulate. The species expands, modifies its environment, builds systems. Then conditions change, resources shift. A stressor pushes the system beyond its capacity to adapt. Collapse follows. Survivors persist, but the technological peak is lost. After enough time, traces fade. The cycle resets. This does not require identical civilizations repeating themselves. Each cycle could look different. Different species, different environments, different technologies. What repeats is not the form, but the pattern. We already see hints of this cyclicity in the biological record. Certain traits evolve independently multiple times. Eyes, flight, sociality. Intelligence itself shows signs of convergent evolution. Cephalopods, corvids, primates, cetaceans. These are not trivial capacities. They arise because certain problems reward certain solutions. If intelligence is advantageous under some conditions, it may arise whenever those conditions appear. If those conditions are temporary, intelligence may also be temporary. Collapse in this sense is not failure. It is a response to changing constraints. From a geological perspective, civilizations would be brief events. Even one lasting 100,000 years would be a flicker. Multiple such flickers could occur without overlapping or leaving durable traces. The reason this idea feels unsettling is that it undermines a deeply held belief. The belief that intelligence represents a permanent step forward. That once a species figures it out, it remains on an upward trajectory. Earth does not guarantee that. The fossil record is full of successful lineages that dominated for tens of millions of years and then vanished. Dinosaurs are the obvious example, but there are many others. Success does not ensure permanence. Adaptation is always conditional. Intelligence may be no different. In fact, intelligence may introduce new vulnerabilities. Complex societies rely on intricate interdependencies, supply chains, information networks, specialization. These systems are efficient but brittle. They function well under stable conditions and poorly under disruption. A simpler organism may survive conditions that collapse a complex system. This is not an argument against intelligence. It is an observation about trade-offs. When we consider cycles of intelligence and collapse, it becomes easier to understand why Earth might host multiple intelligent species over time without accumulating a clear archaeological record of them. Each cycle ends not with a monument, but with reabsorption into the biosphere. Knowledge returns to memory. Memory returns to behavior. Behavior returns to instinct. Instinct returns to biology, and biology is recycled efficiently. There is another dimension to these cycles that often goes unspoken. Intelligence may not always pursue expansion. A species could reach a technological plateau and remain there for long periods. If that plateau is stable and low impact, its visibility would be minimal. Such a civilization might persist quietly until conditions change. When collapse comes, it leaves little behind because it never built massively in the first place. In this case, the cycle would be almost entirely invisible from a future vantage point. Human history itself offers a compressed version of this pattern. Periods of rapid advancement are followed by stagnation or decline. Knowledge is lost and rediscovered. Technologies are reinvented. Ideas resurface in new forms. The notion of a single, linear march toward progress is a modern abstraction, not a universal law. What makes our current moment feel different is scale, global communication, planetary impact, the speed of change. These factors make it tempting to believe we've broken free of cycles. But scale cuts both ways. A global civilization is also globally vulnerable. A sufficiently large disruption affects everything at once. There are no untouched regions to preserve knowledge or seed recovery. This could make collapse deeper and more complete than anything before. From that perspective, our era may not represent escape from cycles, but amplification of them. This brings us back to deep time. Over billions of years, Earth has had many opportunities to host intelligent systems. The conditions required may be rare, but time compensates for rarity. Even unlikely events become probable given enough attempts. What deep time does not guarantee is continuity. The silence we observe in the geological record could reflect not absence, but repetition without accumulation. Intelligence arises, alters its environment, collapses, and leaves behind traces too faint or ambiguous to persist. Seen this way, humanity is not necessarily the first nor necessarily the last. We are one instance in a broader pattern, unfolding under particular conditions. This idea does not require believing that there were advanced machines millions of years ago. It requires only acknowledging that intelligence and collapse are not opposites, but companions. That the same forces that allow complexity to arise also create the conditions for its undoing. Cycles do not imply inevitability, they imply risk. Understanding that risk is not an exercise in pessimism, it is an exercise in realism. It encourages humility. It shifts focus from conquest to resilience, from permanence to adaptability. If intelligence is cyclical, then the most important question is not whether we are first, but whether we can become different. Whether a civilization can learn to persist without triggering its own collapse. Whether it can align itself with planetary cycles rather than fighting them. It begins with a pause rather than a discovery. A moment when a thinking mind stops responding only to immediate needs and starts turning inward, then outward, asking questions that serve no obvious survival function. Questions about origin, about meaning, about whether anything existed before and whether anything will remain after. That pause may be one of the most consistent signatures of intelligence, more consistent than tools, cities, or machines. Once a species becomes capable of reflection, it almost inevitably begins to wonder about its place in time. We often assume that this kind of questioning is unique to modern humans, shaped by our particular history and cultural traditions. But there is nothing especially modern about curiosity itself. It emerges naturally once a mind is capable of abstraction, memory, and imagination. A being that can plan for the future will eventually wonder about the past. A being that can recognize patterns will notice cycles. A being that can communicate symbolically will begin to tell stories about where it came from. There is no reason to believe that we are the first minds on Earth to reach that threshold. If intelligence has arisen before, even in forms very different from our own, it is difficult to imagine that those minds would not have asked similar questions. Not the same questions, phrased the same way, but questions driven by the same underlying tension. The tension between a short individual lifespan and a long, indifferent world. The tension between awareness and impermanence. From that perspective, the question, "Are we the first?" becomes less about evidence and more about probability. Earth has had billions of years to host thinking beings. Even if intelligence is rare, time is vast. Rare events become likely when given enough opportunities. The planet has gone through countless environmental states, many of which we no longer understand well. Different atmospheric compositions, different climates, different dominant life forms. Each of these states represents a different set of constraints and possibilities for cognition. If intelligence emerged under some of those conditions, it would have been shaped by them. Different sensory priorities, different social structures, different relationships to the environment. But the core experience of awareness, of being a thinking entity embedded in a larger system, may have been surprisingly familiar. Once that awareness exists, certain questions follow naturally. What came before us? What will come after? Why does the world change? What causes destruction? What survives? Are we alone in our thinking or part of something larger? These questions are not cultural accidents. They are cognitive consequences. We see hints of this even in non-human animals today. Certain species show behaviours that suggest curiosity detached from immediate reward. Exploration for its own sake. Play. Attention to novelty. Problem-solving that goes beyond necessity. While these behaviours do not constitute philosophy, they point toward the same cognitive roots. Scale that up. Add language. Add memory across generations. Add the ability to transmit ideas symbolically. Questions become inevitable. If earlier intelligent species existed, they may have developed their own ways of grappling with these questions. Not through written philosophy, perhaps, but through shared narratives, rituals, observations of the sky, interpretations of natural cycles. They may have noticed extinctions, environmental shifts, catastrophes that erased familiar landscapes. They may have sensed that the world they inhabited was not permanent, that it had changed before and would change again. That realization alone would provoke reflection. Consider how quickly humans began asking existential questions once basic survival was relatively secure. Cave art appears tens of thousands of years ago. Burial practices suggest symbolic thinking and concern with death. Astronomical observations emerge early in many cultures. Myths arise to explain forces that feel larger than any individual. These behaviours did not wait for industrial technology. They emerged as soon as cognition allowed. So if intelligence arose before, even briefly, it likely went through a similar phase, a period where immediate survival was no longer the only concern, and attention turned toward understanding patterns, origins, and endings. What would such questioning look like without writing? It would look like story, like ritual, like shared memory embedded in behaviour, like seasonal practices aligned with environmental cycles, like cautionary tales about imbalance and collapse. And when those societies disappeared, the questions would disappear with them, unless they were somehow inherited by later beings. Humanity may have inherited fragments of earlier questions without knowing it. not as factual knowledge, but as recurring themes: floods, cycles, lost ages, renewal. These motifs may not be evidence of specific events, but they may reflect the persistence of certain concerns whenever intelligence confronts a dynamic world. There is also a deeper layer to this idea. Questioning itself leaves almost no trace. A thought does not fossilize. Curiosity does not imprint on rock. Reflection leaves no chemical signature. Unless questioning results in durable artifacts, it vanishes entirely when the minds that held it disappear. This means that even if countless intelligent beings before us spent time wondering about the past, the universe, and their own impermanence, we would have no direct evidence of that fact. The absence of evidence does not imply the absence of questioning. It implies the absence of a medium capable of preserving it across deep time. Writing is an extraordinarily recent invention. Even among humans, most questioning occurred without it. Oral traditions can persist for thousands of years, but not millions. Without constant renewal, they fade. If earlier intelligences lacked durable recording systems, or chose not to use them, their reflections would vanish completely. This is an important counterweight to our usual assumptions. We often imagine that if someone had asked these questions before, we would find some sign of it. A message, a structure, a signal. But deep time is not kind to messages. Even our own attempts to send messages into the future are fragile. Time capsules corrode. Languages evolve. Symbols lose meaning. A marker intended to warn future beings about nuclear waste may be misinterpreted or ignored. Communication across millennia is already difficult. Across millions of years, it borders on impossible. So if we are the first to ask these questions in a way that can be preserved, that may say more about our tools than about our uniqueness. There is another subtle reason we may not be the first to wonder about earlier civilizations. Curiosity about predecessors does not require actual predecessors. It requires imagination and pattern recognition. Even if an intelligent species arose without any prior intelligent beings, it would still encounter ruins of sorts. Fossilized life, extinct species, geological layers showing change and disappearance. These observations alone would provoke speculation. Dinosaurs did not know what came before them, but if they had been capable of reflection, they might have noticed that certain forms of life appeared and vanished, that landscapes changed, that stability was temporary. Any thinking species embedded in Earth's systems would eventually confront evidence of impermanence. And impermanence naturally leads to questions about continuity. So earlier intelligences might have wondered not who came before us, but what existed before our world as we know it. The questions evolve with perspective, but the underlying impulse remains. There is also the matter of humility. We tend to see our questioning as sophisticated because it is expressed through science and philosophy. But the act of wondering does not require scientific method. It requires awareness of uncertainty. A species that noticed regular extinctions or environmental resets might develop a worldview centered on cycles rather than progress. Its questions would be framed differently but no less deeply. Instead of asking, "Are we the first?" it might ask, "How long until the next ending?" That is a question rooted in observation, not hubris. Human questioning, by contrast, often assumes linearity, a beginning, a middle, an end, a progression. This assumption may be culturally contingent. Other intelligences might default to cyclic models, seeing rise and fall as natural rather than exceptional. If so, they might not even be concerned with whether someone came before. They might assume that something always did. From that angle, our fixation on being first says as much about us as about the universe. There is also a sobering possibility. Earlier intelligences may have asked these questions and found the answers unsatisfying. They may have concluded that the past is unrecoverable, that the future is uncertain, and that the present is all that can be influenced. If so, they might have turned their attention inward, or toward immediate balance rather than historical reconstruction. That choice would leave fewer traces. Science itself is a cultural strategy. not an inevitable outcome of intelligence. It requires specific values: curiosity, skepticism, accumulation of records, intergenerational continuity. Another intelligence might prioritize harmony, resilience, or adaptation over explanation. If that intelligence disappeared, we would never know that it once asked deep questions and chose different answers. Even within human history, many cultures have not emphasized historical reconstruction. Some focus on maintaining balance rather than understanding origins. Their philosophies are no less complex, but they leave fewer material traces aligned with modern expectations. Now extend that diversity across deep time. It becomes increasingly implausible that Earth hosted intelligence only once, and that this single instance uniquely developed curiosity about its own origins. It becomes more plausible that questioning arises whenever conditions allow, and vanishes whenever conditions change. We are left, then, not with a mystery of absence, but with a pattern of forgetting. Each cycle of intelligence may include a phase of questioning, a moment when beings look backward and forward, trying to situate themselves, and then, if collapse comes, those questions disappear, along with the minds that ask them. Humanity may be unusual not in asking these questions, but in asking them during a period when we also possess tools capable of preserving the questions themselves. That preservation is fragile, but it exists, and it creates a strange asymmetry. We can ask about those who came before, but they cannot answer us. Not because they had nothing to say, but because the channel is gone. This asymmetry can easily be mistaken for uniqueness. There is a final layer to consider. Even if earlier intelligences asked similar questions, they may have reached conclusions that differ sharply from ours. Their answers might not align with our expectations. If we encountered traces of their thinking, we might not recognize them as such. A structure intended as a calendar might be misidentified as a natural formation. A pattern embedded in landscape management might look like ecology rather than design. A long-term environmental modification might be interpreted as climate variation. Recognition requires shared assumptions. Without those, even preserved evidence can remain invisible. So when we ask why we might not be the first to ask these questions, the most honest answer is not that we are certain we're not first, but that nothing about Earth's history guarantees that we are. The planet has had time, the conditions have varied, intelligence may arise when and where circumstances allow. Questioning follows intelligence as naturally as breathing follows lungs. What does feel unique about our moment is awareness of deep time itself, the ability to quantify Earth's age, to understand geological processes, to recognize how incomplete the record is. This awareness allows us to frame the question with unprecedented scope. But scope does not equal novelty. Others may have wondered in smaller frames, with less data but no less sincerity. And that realization reframes the question again. It shifts focus away from proving whether anyone came before and toward understanding what it means to be part of a repeating pattern. What responsibilities come with knowing how easily questions, cultures, and entire intelligences can vanish? If we are not the first to ask these questions, then we are also not the first to face the consequences of ignoring them. If the idea settles in slowly, without drama, it changes the emotional weight of everything that came before, not with shock, not with fear, but with a quiet reorientation. The thought that we might not be the first intelligent civilization on Earth, but simply the most recent one, does not arrive as a revelation. It arrives as an adjustment, a shift in how scale, importance, and responsibility are understood. Being the latest is very different from being the first. When a culture sees itself as the beginning of something unprecedented, it tends to frame its existence around discovery and conquest. The world becomes raw material. The future becomes a destination guaranteed by progress. Mistakes are treated as temporary setbacks because there is always more time ahead, more room to expand, more resources to tap. History, in that framing, points forward. But if we are only the latest, history does something else. It curves, it stops pointing confidently in one direction and begins to resemble a loop, or a spiral, or a series of attempts that never quite settle into permanence. That does not make effort meaningless. It makes context unavoidable. If other intelligences rose before us and disappeared, then intelligence itself is not a finish line. It is a phase, a condition that can emerge, flourish, and fail depending on how it interacts with the systems that support it. That realization removes a comforting illusion. The illusion that intelligence, once achieved, guarantees survival. Earth does not work that way. From the planet's perspective, intelligence is just another adaptive strategy, one that offers powerful advantages, but also introduces new risks. Fire, tools, agriculture, industry, information networks. Each layer of complexity increases reach, but also dependency. Each advancement solves certain problems while creating new vulnerabilities. If earlier civilizations existed and collapsed, then those vulnerabilities are not hypothetical, they are tested. And that changes how we interpret our own moment. It becomes harder to treat current crises as unprecedented anomalies. Environmental stress, climate instability, resource depletion, social fragmentation. These are not unique challenges. They are recurring pressure points in any system that grows faster than its foundations can support. Seeing ourselves as the latest reframes modernity not as an apex, but as a peak that may or may not be sustainable. This perspective does not demand pessimism, it demands clarity. One of the most striking implications is how it changes the meaning of progress. Progress as we usually define it is cumulative. Knowledge builds, technology advances, capacity increases. But deep time suggests that accumulation is fragile. What is built can be unbuilt. What is learned can be forgotten. What is achieved can be erased. If we are the latest, then progress is not guaranteed to be permanent. It must be actively maintained, adapted, and aligned with conditions that allow it to persist. That alignment is the hard part. Every civilization operates within constraints, energy availability, environmental stability, social cohesion, biological limits. If those constraints are ignored or misunderstood, intelligence becomes a liability rather than a safeguard. From this angle, the question shifts subtly but profoundly. It stops being, how advanced can we become, and becomes, how long can we remain coherent? Coherence is not flashy. It does not announce itself with monuments or rapid growth. It shows up as balance between systems, as restraint, as feedback awareness, as the ability to adjust course before collapse becomes inevitable. If earlier civilizations failed, they may not have failed because they lacked intelligence. They may have failed because intelligence alone is insufficient. This reframing also alters how we think about legacy. If we assume we are the first and only, legacy feels like a matter of record. Build something big enough, influential enough, and it will be remembered. Leave a mark, make history. But if we are only the latest, legacy becomes uncertain by default. Earth does not promise remembrance. The geological record does not reward ambition. It preserves accidents. In that context, legacy shifts from permanence to impact. What matters is not whether our cities last, but whether the systems we influence remain habitable for whatever comes next, whether biological diversity persists, whether ecological cycles remain functional, whether intelligence in some form can arise again without inheriting a planet stripped of resilience. This is where the idea becomes ethically weighty. If we are only the latest, then we are not just participants in Earth's story. We are custodians of a transition point. What we do now influences not only our own future, but the range of futures available to life after us. Earlier civilizations, if they existed, may not have had that awareness. They may not have understood the scale of their influence. They may not have known how deeply they were altering planetary systems. We do. That knowledge changes the terms of responsibility. it also changes how we interpret meaning. Meaning does not have to come from being first or final. It can come from being careful, from being attentive, from recognizing patterns and choosing differently where possible. If intelligence is cyclical, then the goal is not to break the cycle by force, but to understand it well enough to navigate it. There is also a humbling psychological effect to this idea. Much of human anxiety about extinction, collapse, or insignificance is tied to the fear of being erased, of not mattering, of disappearing without recognition. But if disappearance is normal, not exceptional, then meaning cannot depend on permanence. It must depend on experience, relationship, and consequence while the system is active. Earlier intelligences, if they existed, may have lived meaningful lives without ever being remembered. Their disappearance does not retroactively strip their existence of value. The same applies to us. This perspective can be strangely calming. It releases the pressure to be immortal as a civilization. It allows focus to shift toward quality rather than duration, toward how intelligence is expressed rather than how long it dominates. Being the latest also reframes curiosity about the past. Instead of searching desperately for proof that others existed, the question becomes what patterns we share with anything that might have existed before. Did they struggle with sustainability, with inequality, with managing powerful tools responsibly, with balancing short-term gains against long-term stability? If so, then the lesson is not that we are doomed to repeat their fate, but that intelligence faces recurring challenges that require recurring solutions. We often frame collapse as a moral failure, as punishment for hubris or ignorance. But collapse can also be understood as a systems failure, a mismatch between scale and control, between speed of change and capacity to adapt. If we are only the latest, then collapse is not an indictment of intelligence. It is a reminder that intelligence operates within constraints it cannot ignore indefinitely. This has implications for how we think about the future. Instead of assuming that technology will automatically solve the problems it creates, we may need to treat technology as one tool among many, insufficient on its own. Social structures, cultural values, ecological understanding, and long-term planning matter just as much, if not more. Earlier civilizations may have reached technological sophistication without developing equivalent systems of restraint, or they may have developed restraint that worked for a time until conditions shifted beyond their control. Either way, the outcome would look similar in deep time: rise, activity, disappearance. Recognizing that pattern does not tell us exactly what to do, but it narrows the range of useful responses. Unchecked expansion looks less like destiny and more like risk. Environmental disregard looks less like a temporary cost and more like a potential endpoint. Ignoring feedback looks less like optimism and more like denial. If we are only the latest, then humility becomes a practical strategy, not a philosophical preference. Humility in the face of complexity. In the face of planetary systems we do not fully control. In the face of timescales that make individual civilizations brief. This humility does not require abandoning ambition. It requires aligning ambition with survivability. There is also a narrative shift here. Human stories often cast the present as a turning point, a moment where everything changes forever. That may still be true, but not in the way we usually imagine. The turning point may not be about achieving dominance or escaping limits. It may be about deciding whether intelligence can coexist with the processes that make Earth livable. If earlier intelligences existed and failed, then we have inherited not their achievements but their warning, even if we cannot read it directly. The warning is embedded in the planet itself, in the cycles, in the erasures, in the silences. Being the latest means we're reading the story from inside one of its brief bright moments, not from the end. And that brings a certain urgency, but not panic. Urgency grounded in awareness. We're capable of seeing the pattern while we're still inside it. That may be rare, it may be new, Or it may be another recurring phase, one that some previous intelligence reached as well, only to be overtaken by events before they could act on it fully. Either way, the opportunity exists now. Another implication of being the latest is how it reframes contact, both hypothetical and real. When we search the universe for intelligence, we often assume that advanced civilization should be obvious, loud, persistent, technologically expansive, but Earth suggests a different possibility. Intelligence may be common and quiet, brief and difficult to detect, cyclical rather than continuous. If that is true, then the silence we observe beyond Earth may not mean emptiness, it may mean transience, and that loops back to us again. If intelligence elsewhere follows similar patterns, then our own future is not just a local question. It becomes part of a broader cosmic pattern of emergence and disappearance. That does not make it less important, it makes it more representative. There is dignity in being part of a larger pattern, even one that does not promise permanence. The final implication of being the latest is subtle, but profound. It challenges the idea that history is something behind us. If intelligence cycles, then history is also something ahead of us. Future intelligences, whether human descendants or something entirely different, may look back at our traces and wonder similar things. They may ask whether we were the first, whether we understood our limits, whether we left the world capable of supporting thought again. We cannot control how we will be remembered if we are remembered at all. But we can influence what conditions we pass on. If we are only the latest, then the most meaningful question is not how long our civilization lasts, but whether intelligence itself gets another chance. That is not a poetic question. It is a practical one. It depends on decisions being made now, often quietly, often without fanfare. Decisions about energy, land use, biodiversity, cooperation, and restraint. Decisions about whether short-term advantage outweighs long-term viability. Earth does not grade on intentions, it responds to outcomes. Earlier civilizations, if they existed, may have learned that too late. Or they may have learned it and still been overtaken by forces beyond their control. We do not know. What we do know is that we are here now, aware of deep time, aware of erasure, aware of cycles. Being the latest means we're standing at a familiar threshold, even if we do not know who stood there before. And what comes next will not be decided by whether we were first, but by whether we understand what it takes to avoid becoming just another quiet layer in the planet's long habit of moving on. Sometimes the thought arrives late at night, not as a question you actively chase, but as one that drifts in when everything else has gone quiet. The lights are off. The day has receded. Your body is still, but your mind is awake, lightly alert, aware of the slow rhythm of breathing and the faint sounds of the world continuing outside. In moments like that, it becomes easier to feel how old the ground beneath you really is. Not to calculate it, not to measure it in years or numbers, but to sense it. The planet does not announce its age. It carries it silently. Every layer of rock beneath your bed, your chair, your city has already lived through more change than the human mind is built to intuitively hold. Mountains rose and vanished where you now lie awake. Seas advanced and retreated. Forests came and went. Entire ecosystems flourished, collapsed, and left no names behind. And here you are, briefly conscious on top of it all, listening to a story that is far larger than you, yet somehow includes you anyway. There is something grounding about that realization when it arrives gently. It shrinks urgency without erasing importance. Your worries do not disappear, but they change scale. They stop feeling like the center of everything, and start feeling like part of a wider pattern of concern and care that countless beings before you must have felt in their own ways. Lying awake on a very old planet invites a particular kind of humility. Not the kind that diminishes you, but the kind that places you. You're not outside the story and you are not its conclusion. You are one conscious moment within a sequence that stretches backward and forward, far beyond your view. What makes this moment unusual is not that the planet exists, but that it is being noticed by you right now. Earth has spent most of its existence unobserved in this way. Life existed long before minds capable of reflection appeared. For billions of years there was activity without awareness, motion without commentary. Rivers flowed without being named. Ice advanced without being remembered. Extinctions happened without being mourned by anyone who could grasp their scale. Then gradually awareness emerged, not all at once, and not everywhere. Small pockets of perception began noticing patterns, recognizing change, anticipating outcomes. Eventually, some of those minds began wondering about the past and the future, about what came before and what might come next. That wondering is fragile. It depends on continuity, on memory, on enough stability to allow thoughts to extend beyond immediate survival. And yet, here it is, alive in you at this moment, drifting through your mind as you lie awake. There is a quiet intimacy in realizing that you are sharing this planet, not just with other living beings now, but with an uncountable number of past lives that once occupied the same physical space in different forms. Every atom in your body has been part of other things, stars, oceans, organisms. Nothing here is new, only the arrangement is. That thought can feel unsettling if you rush it, but if you let it settle slowly, it becomes calming. It suggests continuity without permanence, participation without ownership. You're not responsible for carrying the entire story of Earth. You're simply part of the chapter currently being written. When people talk about the possibility of earlier civilizations or cycles of intelligence rising and falling, it can sound abstract during the day. But at night, when the usual noise recedes, the idea feels less like speculation and more like context. Less about proving something, more about understanding what kind of place you are actually in. Earth is not a static platform designed to host one successful species indefinitely. It is a dynamic system that supports complexity when conditions allow and dismantles it when they do not. That process is not cruel. It is indifferent. It does not aim. It responds. Lying awake, it becomes easier to imagine how many moments like this may have occurred before, even if no record remains. Other beings, under other skies, resting on different versions of this planet, experiencing their own quiet awareness before sleep. They may not have had language like ours. They may not have framed their thoughts the same way, but awareness does not require philosophy to exist. It requires only the capacity to notice. If intelligence is cyclical, then moments of reflection may be as well, brief windows where the planet becomes aware of itself through the minds it supports. Windows that open, linger for a while, and then close. That does not make them insignificant. It makes them rare in a different way. What often goes unsaid in discussions about ancient civilizations is how much of existence is lived without expectation of permanence. Most organisms do not assume the future will remember them. They act, adapt, reproduce, and disappear. Meaning is not derived from legacy. It is derived from function and experience. Human intelligence complicates this by introducing the desire to be remembered, to leave something behind, to matter beyond the present moment. That desire is understandable. It is also a source of anxiety. Lying awake on a very old planet can soften that anxiety. It reminds you that meaning does not depend on geological endurance. The planet does not validate existence based on how long traces last. It simply allows life to happen while conditions permit. Your thoughts right now matter because they are happening, not because they will be preserved. There is also a strange comfort in recognizing that Earth has survived far worse than any single civilization. Asteroid impacts, supervolcanoes, global ice ages, atmospheric transformations. The planet has been reset repeatedly and continued on, reshaping itself and allowing new forms of life to emerge. This does not mean that everything is fine or that consequences do not matter. It means that fear of total erasure is misplaced. Earth does not end when civilizations do. It continues, changed, carrying forward whatever can adapt. For someone lying awake, this can feel like a quiet reassurance. Not that nothing matters, but that panic is unnecessary. The planet is resilient in ways that individual systems are not. At the same time, that resilience should not be confused with forgiveness. Earth recovers, but not for us. It recovers for itself. The conditions that allow human civilization to exist are specific and fragile. They are not guaranteed to return in the same form if lost. This duality is important to hold gently. Earth will continue. Whether we do is a separate question. Lying awake gives space to hold both truths without needing to resolve them. There is also something deeply human about contemplating these ideas at rest. Throughout history, nights have been when stories were told, questions asked, and fears named. Darkness reduces distraction. It pulls attention inward. It creates a natural pause in activity that invites reflection. In those pauses, people have always wondered about what came before, about ancestors, about lost times, about why the world is the way it is. Our modern questions about ancient civilizations are just the latest expression of that impulse. The difference now is scale. We know how old the planet is. We understand geological processes. We have evidence of vast spans of time that dwarf our existence. That knowledge can feel heavy if you carry it all at once. But it can also feel oddly comforting when approached slowly. It tells you that uncertainty is normal, that not knowing everything about the past is expected, that the gaps are not failures of curiosity, but features of a world that does not preserve everything. It also tells you that your role is not to solve the entire mystery, but to be present within it. As you lie awake, you may notice how your body feels against the surface beneath you. That surface is part of Earth's crust, directly or indirectly. It is moving, even if imperceptibly. Plates drift. The planet rotates. You are never truly still. That motion connects you physically to deep time. You're riding the same tectonic processes that shaped continents long before humans existed. You're part of the same carbon cycle that has moved atoms through countless organisms. Nothing about you is separate from the planet's long history. And yet, your awareness is momentary. That contrast is not a flaw. It is the point. Civilizations, like individuals, are temporary expressions of deeper systems. They arise when conditions align. They persist while balance holds. They fade when pressures exceed capacity. The Earth does not grieve this. It adjusts. Understanding this does not require resignation. It invites attentiveness. If intelligence is something that appears intermittently on this planet, then the moments when it exists are precious. Not because they last forever, but because they allow the planet to be experienced consciously. You are part of one of those moments. Lying awake, it becomes easier to appreciate that fact without needing to elevate it into destiny. Awareness itself is enough. There is also a subtle shift that happens when you stop thinking of Earth as a stage and start thinking of it as a participant. The planet is not merely hosting events, it is shaping them. Its chemistry, physics, and dynamics determine what is possible at any given time. Earlier intelligences, if they existed, would have been shaped by different versions of Earth, different climates, different atmospheres, different ecosystems. Their questions would have been different in detail, but likely similar in spirit. That continuity of questioning, rather than continuity of civilization, may be the most persistent feature of intelligence on Earth. Questions arise. They are held for a time, then they disappear along with the minds that ask them. You are holding some of those questions now. You may not answer them fully. That is not a failure. It is a shared condition. The planet does not expect answers. It continues regardless. This perspective can ease the pressure to conclude, to solve, to finalize. It allows thought to drift without needing resolution, which is fitting, because sleep itself is a surrender of control, a trust that the world will continue while consciousness steps aside for a while. As you listen, or think, or simply rest with these ideas, there is no requirement to reach a conclusion. The story does not need an ending. It has been unfolding for billions of years without one. You're allowed to be part of it without understanding all of it. Perhaps that is the quiet lesson hidden beneath the question of ancient civilizations. Not that we must know who came before, but that not knowing is acceptable, that humility is appropriate, that awareness does not require certainty to be meaningful. Earth does not reveal all of its history. It reveals enough to remind us that we are late arrivals and temporary guests, and that is not a cause for despair. It is an invitation to pay attention while we are here, to act with care toward the systems that support awareness, to recognize patterns without assuming exemption, to value experience without demanding permanence. Lying awake on a very old planet, it becomes possible to hold all of this gently, without urgency, without fear. The ground beneath you has been here far longer than any story you know, and it will remain long after new stories begin. For now, you are part of the one being told, and that, in this quiet moment before sleep, is enough.